two, two. Here and two.
All right. Welcome, everyone. Good morning. Good morning to the people in the overflow room. Channel surfing first thing out of the gate. Bold move. Like it. So I decided that I wanted to give this talk because back in the mid 2010s, there was kind of this industry-wide push to start moving everything to the cloud. So everyone was kind of drawn by this pie-in-the-sky dream of having unlimited computing power, unlimited memory, unlimited storage. So, hey, we are no longer bound to the hardware that we're running software on. We're going to run everything in the cloud. It's going to be amazing. We're going to have infinite growth. And the thing is that a lot of these projects didn't really start to pan out. So a lot of them ran over time. They ran over budget. Some of them were canceled altogether. And I have been a part of a couple of these in different cloud platforms, in different industries. And I am very proud to say that I now have a cloud-native, scalable system running in production. But it was a bit of a difficult challenge getting here, and I have learned some things along the way, both from successes and from failures. So I wanted to take, 50 minutes and reflect on some of the things that I have learned along the way. And when I was trying to structure this talk, I was thinking about the fact that scalability kind of comes into play in the entire software development cycle. So every stage of the way, there is something to be considered when it comes to cloud scaling. And so I started to kind of structure the talk that way, but I found that I kept looping back to earlier topics and then jumping ahead. And I realized that in the same way we can't really build software this way, I couldn't really do the talk this way. So my first point is that waterfall is not going to work for a scalable cloud system. If you haven't already, you need to adopt some kind of DevOps transformation. And it doesn't really matter whether it's NoOps or platform engineering or whatever trendy DevOps replacement you particularly prefer. The point is that you need to be able to loop back and revisit the decisions that you made later. Because to build a system that can react to change, you, as a person, as an organization, as a team, also need to be able to react to change. Planning everything up front just isn't going to work anymore. There are too many variables that need to be kind of planned for, that need to be taken into consideration. And even if you have the best plan, things don't always go the way you expect them to. So when I was thinking about this, I don't know if any of you have read Octavia Butler's Parable of the Sower. She introduces this concept called Earthseed, which is all about how the only constant is change, and God is change. So I kind of feel like that is the modern cloud development fundamental principle, is that everything is change. Everything is going to change. The system is changing. So you need to be able to change with it. And that pretty much means adopting DevOps. And when my first team adopted DevOps, I worked for a large enterprise organization. We had incredibly strict standards on handling customer data. And I looked at this whole DevOps concept and I said, what, there is no way that they are ever going to let me see this super valuable customer data. We run all over the world. There's no way that they're expecting me to be up in the middle of the night making sure that this system runs. And it's a system that I probably don't even have the legal right to look at anyway. But the thing is that even if you aren't ops for production, you are going to be ops for your development environment. Because you need to know what your system is doing. If you just hand it off to somebody else, you don't really know if it's working or not. And you need to be the ones knowing whether it's working. Because you need to be able to test it. And the biggest reason that I restructured this entire talk was because I kind of wanted to put testing first, or as close to first as I could. If you take nothing else away from this, test your scaling. Test your scalability, make sure that it works. Everything else is completely moot, and you can figure it out along the way. Because if you're not testing it, you don't know what's going wrong, you don't know what's going right, and you can't change it. So One of my other principal learnings from from the years and the projects that I've been doing this is that you do not know that your system will scale until you have seen your system scale. So when I joined the project that I'm on now, basically they said, oh yeah, when the load increases, the system is going to scale out. We've designed it that way, it's going to work that way. What ended up happening was that the first time we tested this, that did not happen. So the system scaled out, and we were using app services running on app service plans. So FYI, a lot of this talk is going to be a little bit Azure leaning because I'm working on an Azure project right now, but the fundamental principles really apply to whatever cloud platform you're working on. So we were running app services on app service plans, and we saw that the app service plans were scaling out, and everybody said, oh, it's fine. The app service plans are scaling out. Look at them. You can see that they're scaled out. Everything's great. But the thing was, we weren't actually getting any more traffic through the system. And what actually was happening was that even though the app service plans were scaling out and the apps were technically scaling out with it, they weren't actually, the second instances and the third instances, all the way up to the nth instance, weren't actually starting correctly. So even though everyone said that the system was scaling, it wasn't really scaling. So I have a good friend who is also a developer, and my friend's husband is completely non-technical. And so he ends up having to hang out with a bunch of developers talking shop and talking about technical things. And kind of his little party trick is whenever things get a little bit too complicated, he throws in, yes, but will it scale? And the thing is, it's a good question. But what he should be asking isn't will it scale, it's does it scale? Because until you have tested it, you cannot say that it does scale. So how do you test it? When we first found that our app service system wasn't scaling the way we thought it was, basically we just had a developer who had written a script that hit our system over and over and over again. And it was during a low period, Romuald, in between Christmas and New Year's, and we basically found every single developer in the company who happened to be working on those days, and we gave them this script, and we said, could you please run it? And so everybody started hitting the system at the same time, and it triggered the memory load and the CPU load, and so we started to see it scaling and found out that it didn't actually work. And the thing is that is not a very elegant solution. But the thing is that any testing is better than no testing. So just start with something. Just find a way to put load onto the system, and it doesn't have to be the greatest solution, and it doesn't have to be the final solution, because just like the system that you're testing, you can change it. So find out what works, find out what doesn't work, and practice continuous improvement on your testing cycle as well. Another question is when to test. And of course, the ideal answer is to test after every single change. In reality, that's probably not going to happen. Usually load tests end up taking a little bit more time. You can't necessarily run them on every single push. More realistically, test it before every release, even if you have really short release cycles. So every day, every week, depending on how long your tests run, depending on how often you release. Consider having a load test smoke test suite. So take your most critical pieces or the things that go wrong the most often and test them as often as you possibly can. Because the thing is that it's easier to identify problems if you've only made a few changes when the problem shows up. And this is one of those things that we have learned the hard way. So my team has grown over the last year, and we have some growing pains with it. And we got to the point where we had lots and lots of changes going in at the same time, which is great from a productivity standpoint. But then at some point, the load tests started showing incredibly problematic performance results. So things just weren't working. And the problem was that because we now had more developers than we had had previously, it meant that we had more changes that had gone in than previously. So we basically had to pick apart everything that had been changed in that past sprint and take everything out one by one and keep retesting and retesting until we figured out where the problem actually lay. Then we had to take that out of the release and put everything back, which really ended up just kind of costing us more time than it would have been if we had just slowed down and made sure that we tested each of those releases one by one. So one of the things that we're doing now is that we are flagging any kind of change that we think has a high potential of impacting the system, and we're doing a little bit more planning upfront to kind of make sure that we have the opportunity to test in between each of those changes. So why is testing so important? I think it should be obvious, but no matter how much you plan for, there is going to be something that goes wrong. You probably aren't going to think of every single thing up front. We are human. There are a lot of variables in a cloud system. If you're running on PaaS, you have all kinds of connection points. You have all kinds of nuances of the services that you are building on. It's just unlikely that you are going to be able to figure everything out ahead of time before you test that it's actually working. This is actually a quote from Robert Burns. It was originally written in Gaelic. I'm going to make or Scots, maybe Scots. I'm going to make my best attempt at the original so that you have something to laugh at later, which is, the best laid schemes o' mice and men gang aft agley. And I think it's a very valuable piece of information to remember in English, or if you want to translate it into Norwegian, I will let you do that. But it's good to keep in mind, because no matter how well you have planned, there is a very good chance that you have missed something. So unfortunately, I have an example of this one too, which is that I work on a system that basically does a lot of data indexing. And we needed a way to be able to kind of restructure that index when we needed to. So to be able to shift from one index schema to another in live production without impacting anything, and preferably as soon as possible, in the shortest amount of time as possible. So we sat down and we looked at our system and we came up with some fantastic sequence diagrams, and we figured out where we could inject the transition code and how we would actually make this work. And we iterated over the design, and we had a couple of developers who were discussing it and throwing in ideas, and we said, oh, we can use this new technology that scales faster than what we are currently running on, and if we do this, it's going to be super fast, and we're going to be able to do this transition in like a very, very small amount of time. And we built it, we developed it, we tested it in our development environment, and we handed it over to our staging testing environment. And the first time we actually tried to run it at scale, we hit the problem that we had not seen coming, which is that it actually ran too fast. So all of our computing was happening super quickly, and we were plowing. We had, designed it so that we could break this giant workload into small pieces and run them all in parallel and scale out to handle all of these little pieces of work that needed to be done. And we ended up exhausting the socket limits on the data storage that was actually feeding data into the indexing. So then we had to basically scrap the entire beautiful too fast design and find a way to explicitly slow it down so that we could actually get through all of the data without exhausting that socket limit, which was, number one, frustrating, number two, terrible for the timeline, and number three, just heartbreaking because we had spent so much time on this thing. And it was too fast. How often does something run too fast? So another point in testing is that it is worth testing on as close to production specs as you can. This isn't always possible. Sometimes production systems are hugely and prohibitively expensive. I recognize that. But if it is at all possible, it is worth testing on the same kind of specifications, the same hardware, the same service tiers that you're actually going to be running in production. Because if you aren't actually testing the system that you will be running in production, to some extent, your tests are actually going to be a little inconclusive because things will behave differently. You will probably find bottlenecks in different places. So ideally, yes, test the same thing that you're actually going to be running in real life. That also means testing the same load that you are expecting in real life. It can be easy to overestimate the amount of load that your system needs to handle. That's not a terrible problem, but it could mean that you are wasting resources, that you're spending too much development effort handling something that isn't actually going to happen. But of course, even worse is underestimating, because then who knows what's actually going to happen when the system really starts running. Another thing to consider is that it's very easy in load testing to build in kind of spikes of activity. And there's a lot of talk, especially if you're working on a scalable system, that, oh, the whole point is to design the system so that it can handle those activity spikes. Something exciting happens in the world, and all of a sudden there's more traffic on your system than you were expecting. But the thing is that those aren't really, there's a difference between a spike and a cliff. And load testing can often go from 0 to 60 in 0 time. And that's not necessarily what's actually going to happen in real life. Maybe it is. Maybe you have some kind of, you're selling concert tickets and they go on sale at a specific time, so you go from no traffic to all the traffic. But for a lot of scenarios where we're talking about spike traffic, we're actually just talking about a really steep escalation. So think about how your actual traffic patterns, including those spike scenarios, are going to work, and try to design your tests to mimic that. Because if you are designing a system that is going to go from if you're testing a system that goes from 0 to 60 in 0 seconds, then you're going to end up building a system that goes from 0 to 60, and it can really be difficult. So you're going to make decisions that maybe aren't necessarily the ones that you would be making if you were actually looking at realistic traffic patterns. So yeah, think about how fast that traffic load or whatever you're scaling for is actually going to increase. But yeah, when it comes to figuring out that expected load, it's hard. A lot of the time, product owners don't necessarily know the numbers. So if you have the opportunity, try to observe a real user, especially if you're taking a system that already exists and you're building a new version. It is invaluable to actually see someone using the system. Preferably an expert user who's going to do those things that happen at speed that you may not get from a developer clicking around testing the things that they've been working on. So I work on a system that does, among other things, it runs a picture desk for large media organizations. So as news feeds are coming in, as photographers are taking pictures of world events, all of those are being fed into the system, and then the newsrooms can look at them and figure out which pictures they're going to use in production, which pictures they're going to save in their archives, things like that. And we were very, very fortunate to have one of those big newspapers let us sit down with one of their senior picture editors, photo editors, and actually watch her work for a few minutes, 15. I think we had a half-hour schedule with her, and she really wanted to explain what she was doing, like why she was clicking on things, because she's a journalist, she's not a software developer. Why would a bunch of software developers want to watch her work for half an hour? So she was saying, oh, well, I'll do this because of this reason, and I'll do that because of that reason, which is super useful from a product development standpoint, but from a scaling standpoint, really we just kind of wanted to know, how do you actually work? How fast do you scroll through that? How often do you click on those things and drag them over there? Like, within this 1 minute time frame, is that how fast you would actually be doing that? And she, of course, thought these questions were very strange, but we got so much information out of it. And we had one of our QA automation engineers with us, and he took all of that information back, and he basically codified it into our load tests. So now we have an automated system that basically simulates, 50, 100 versions of her using the system. So that way we know with a little bit more confidence when we go into production that if something happens and the entire world news organizations pull everybody in to work on it, that we can actually handle it. And the last piece of testing based on reality is use a real-world data set. So a lot of the reasons that we started to move to cloud-native development was to be able to handle larger data sets than we can on on-prem bare metal systems. That means quite often a lot of data. It's not always easy to find that much data. So one of the options for for working around that problem is, if you can simulate it. So we don't actually have giant news organization media streams coming into our test system. So we don't actually have as much information as we would in a real world scenario. So we work mostly with metadata, which is information about pictures that gets embedded into the picture as XMP. And we were originally testing with images that didn't really have that much metadata, which meant that we weren't really stressing our indexing system to the level that it would be in the real world. So instead, what we ended up doing was taking kind of some of the pictures that we do have, we can inject information into them, even if it's completely nonsensical. At least we have data that we can kind of fill our indexes with to see what happens when we have more information stored. But also we were able to get a smaller set of some photos from Reuters that have kind of the realistic information that you would find in these newsfeed photos. So then we could take that small data set and basically just extrapolate it and end up making a much larger number. So I think we started with a few, like maybe 1,000 pictures, and we managed to extrapolate that out to a couple of million. In other cases, you can't really fake it. So earlier, I was working on some geological modeling software, and that is not necessarily information that a bunch of software developers are going to be able to fake easily. You can't just lorem ipsum your way through geological layering. And we had a test data set which was based on publicly available data. But the problem with the publicly available data was that it was a lot sparser than what our customers would really be working with. So we were trying to feed it through the system, but whereas an actual commercial environment would be having tons and tons of data coming in from each of the data points that we had available, we had a very, very small subset of that. And so we found that the system wasn't really behaving the same way as it would when we actually gave it real data with all of the fidelity that comes with actual commercial production data. So even though we're still talking about testing, designing load tests is actually one of the best ways to clarify the load requirements. So yeah, defining load tests helps define the requirements, because your product owners don't necessarily know how to come up with such abstract numbers. You say, well, how often is this going to happen, or how many users are going to use this, or how fast are they going to be working on something? Those are better questions than, well, how much load does it need to accept? Because if your product owners are coming from more of a business or domain background, they probably aren't going to be able to say something like, oh, well, we're getting X number of requests per second, so that's, let's add 10% as a margin of error, and that should be good. Especially if you're working on a system that doesn't already exist. So if you're kind of greenfield project, then you really need to start having these discussions. If you have the benefit that you're actually working on a replacement for a system that already exists, if you have good usage numbers for that, then that is a very, very good place to start. But basically, if you start talking about the load testing early, you will start having the conversations that you need to have a lot earlier. And it's important to start those conversations as early as possible so that you don't back yourself into a corner. And speaking of backing yourself into a corner, do not let people front load features, because there's kind of this historic model of software development, which is, okay, yes, we have this piece of functionality, and when they're all done, we're ready. But I think we've all gone over minimum specs enough that we understand the concept, but it's worth repeating it in the context of scalability. Because a million features that don't work at scale are a million features that you are going to have to refactor. And the thing is that you don't even know if you're going to be able to refactor them, because if you have to make some kind of huge fundamental change to the infrastructure in order to support the scaling numbers that you need, it could be that that shiny little piece of tech that was handling some fantastic new feature that everybody was in love with isn't actually going to work at scale, and you may not actually be able to deliver what everyone thought you already had. So it's important to iterate over your design, because you are going to learn things along the way, and you are going to have to make those changes. So even if you think that something worked up front, even if you So if you think that it worked up front and you find out that it didn't, you're going to have to go back and design. But as you're designing, you may actually run into some of those limitations ahead of time. So basically, the idea is that don't set anything in stone and just reiterate over everything. One of the things that is worth designing up front, to the extent that you can, is your infrastructure, because infrastructure isn't always, you can always change it, but it isn't always easy to change it. So I had no idea before I started putting this talk together that you could actually change a tire on a moving car. I am very impressed. I do not think I want to be doing it. Unfortunately, in my real job, I am going to be doing it, because even though we have a commercial system, we do actually have some things that we need to change. And it is incredibly more complicated to change them as things are running. So part of design is, of course, testing. So if you are looking at a piece of infrastructure, build a proof of concept, test your proof of concept, and do whatever you can to de-risk those decisions, because it's going to be very, very, very difficult to change them later. I'm not saying it's impossible, and I'm not saying that you shouldn't do it. I'm just saying that you may be the guy hanging out of a car changing a tire on the highway. So when it comes to designing for scalability, a few general guidelines is, of course, fail fast. Don't spend so much time on something that you end up losing all of that time if it isn't going to work out. It's better to know sooner that something isn't working than to get too far down a road and try to answer all of the questions and then find out that it's not going to work. So right now, I told you that we are changing a big piece of infrastructure in production. And the thing is that a lot of the devs on my team keep looking at every single little nuance and every single little detail and trying to answer all of the questions about, okay, well, if we switch to this piece of infrastructure, how are we going to change this? What are we going to set that to? Is it going to work here in exactly the same way? We need to figure out a setting for this particular property. How should we set that up, and how can we determine what that should be? And the thing is that these are a lot of decisions that need to be made, but they don't necessarily need to be made now. So we need to find out first and foremost whether this is going to work at all. And then once we have an idea that it's going to work, and once we've tested that it's going to work, so we know that it will actually do at least some of the job that we have asked it to do, then we can start going back and answering those little detailed questions. And yes, there is a chance that maybe one of them will end up being a blocker, but chances are that they're just things that we need to sort out. They're things that we need to test, they're things that we need to iterate over, and they don't necessarily have to be decided up front before we make the go, no-go decision. Kill your darlings. This is a term that actually comes from writing fiction. And it's basically a guideline for writers to be ruthless in their editing. And the idea is basically don't get too attached to particular pieces, designs, in the case of fiction writing, little bits of prose that you're absolutely in love with. The idea is to keep the big picture in sight all of the time and just not to basically do your design around the thing that you don't want to get rid of. And if you've worked in software long enough, you probably have met somebody who has some little piece of code that maybe not everybody loves, but they have poured their heart and soul into it, and they are going to keep it around no matter what, no matter how hard it is for anybody else to work on it, no matter how unreadable it is. And the thing is, we need to kind of step away from that mindset, and we need to just say, okay, you know, I really like what we've done, I really like what I did before, but it's time to let it go and move on. So yeah, the TLDR version is, if it isn't working, let it go. And don't assume linear growth. So when you're designing, there's kind of this idea that, okay, well, with one instance of the service running, we can process n requests per second. With 2 instances of the service, we can process 2n. Surely 3n, 4n, it's going to extrapolate. And I think if the mythical man month has taught us anything, it is abundantly clear now that adding a single instance does not necessarily lead to linear growth. Compare adding one more developer to adding one more service, and the number of communication paths are just going to increase exponentially. In some cases, yes, linear growth is possible, it is straightforward, and it is easy, but basically don't assume that. And a better guideline is just to not assume anything. Test it, find out. So the design questions kind of come back to the who, what, when, where, why. And for the what, it's worth asking yourself what needs to scale. So not everything actually does need to scale. If you have something that's running as kind of a one-off process, some kind of system configuration, it probably doesn't need to scale out with the amount of load that the system has or the amount of growth of the system. Maybe it does, maybe it doesn't, but it's worth actually asking yourself, does this actually need to scale? And if it doesn't need to scale, then unless you have a framework in place that makes it come for free, don't spend extra time making it scale if it doesn't need to. Again, you're going to test it, so you're going to find out later if it needs to scale, and if it does, then you can add it in. And how to scale. So there are 2 different concepts of scaling, and in case they are new to anyone, I will go through them briefly, which is scaling up versus scaling out. And I'm going to give an example with planes, because I really like airplanes. I used to fly a lot back before the plague. And this is a little Embraer, and it's an Embraer 170. I come from the Midwestern US. They use these to get from place to place because there aren't a lot of people traveling in the Midwest. And an Embraer 170 can carry 78 passengers. And yes, I am aware that an airplane cannot fly that high, so this is not to scale. So you have 78 passengers fitting on an Embraer. What happens if you actually need more traffic? Something happened in the Midwest, and now all of a sudden, people are going from point A to point B more than we had anticipated. The easy option and the straightforward option is to scale up, which is basically we run a bigger plane. Now we have an A380. It carries 853 passengers. That's a lot. It was super simple. Okay, logistics aside, because I know that actually running an A380 out of an airport is very difficult, but conceptually, all we did was make the plane bigger. The pros, it's easy. It's straightforward. The cons, maybe we don't actually have 853 passengers, and that plane is flying empty half the time. It's very difficult to adjust, and one of the biggest cons is that there is a hard limit. So the A380 is currently the largest passenger jet out there. So if you have more than 853 passengers, this is not going to be a solution that works. Leaving beside the fact that we probably aren't going to run it at full capacity, which means that we are wasting a lot of resources running such a big plane. The other option is to scale out, which very simply means that we put more planes on the route. The advantage here is that it's adjustable. So, you know, we have more traffic, we can run more planes. We have less traffic, we can run fewer planes. The cons is that it's a lot of added complexity. So which plane do you put each passenger on? When do you know that you're going to need more? When do you know that you're going to need less? And how do you maintain an even distribution across them? So some things that you would want to scale up, or probably would want to scale up: throughput. We run with a Cosmos DB database, which is basically a pay-for-what-you-use model. So when we actually need more throughput, then we scale up the throughput on the database access. Storage, pretty obvious. You need more disk space, you use a bigger disk. And for intensive computation, and this is one that kind of was one of the myths of the cloud, which was, oh, we have infinite computing power. And in some cases, this is actually true. If you don't actually want to pay for a whole bunch of users to have really, really high CPUs, then yeah, you can build a system that basically rents them from someone else, and you can actually give them more CPU power for things that actually need more CPU power. For scaling out unrelated tasks, the obvious one is network traffic. So if you have 2 unrelated network requests, farm them out to 2 different instances of the service. Similarly, I mean, everybody's been harping on microservices for years, but this is one of the reasons for that is if you have 2 different services that are doing 2 different things, put them in 2 different services so that they can run separately. You're not competing for computing power between the 2 of them. You're not competing for resources. Independent data, if you're working on some kind of per customer data model and you're getting too much data for whatever component you are storing things in, consider farming that out so that you end up with 1 instance of that data storage solution per customer. If you have unrelated data that doesn't need to live together, you can do the same thing. And the last one is the divide and conquer algorithm, which is kind of where the promise of cloud scaling comes into play. So my first cloud project was actually to take a very computational, intensive algorithm and start running it in the cloud so that we wouldn't have to have the limitations of storing the data on on-prem hardware. We wouldn't have to force our customers into paying for really, really large-scale processing specs. We could run this in the cloud on incredibly high-powered CPUs, and we could store all of the data in the cloud. And the storage part worked out, but the computation was still a big bottleneck. And the thing is that we had basically just lifted this computationally heavy process and just started running it on cloud computing prep. And maybe what we should have done is figure out if there was a way that we could actually have broken that down and farmed out part of that computation into different pieces. So if we had adapted it into more of a divide and conquer algorithm where we could actually split it across multiple services, multiple CPUs, we probably wouldn't have had that bottleneck. I don't know if it's possible. Maybe it is. I hope that it is, and I hope that that has happened, but we'll see. So the last one is when to scale. And this is kind of one of the most challenging problems, is if you are already hitting your limits, it's probably a little bit too late. So basically, you are being asked to forecast the future. And that is a very, very difficult problem to solve. Some infrastructure scales automatically. That stuff is great. I love it when you can just say, okay, yeah, if you need more resources, please take them up to the hard limit so that we don't go broke. Not everything has that ability. So when you're thinking about when to scale, consider the bottlenecks. Most often, that's going to be memory or CPU. And learn from experience. And the way you get experience in the way that you get input is by monitoring. And yeah, I actually have some colleagues who really don't want to do anything operational related, and they think that should just be farmed out to another team. But the thing is that monitoring generates the input to iterative development. because testing doesn't really add much value if you don't actually know what's happening. So you need to be able to monitor the system when you test the system so that you can actually learn from the system. And one of the first questions when you talk about monitoring is, what should you be monitoring? And the short answer to that question is just monitor everything. It is much easier to just get all of the data and look at all of the data and then filter out what actually makes sense and what's important. If you aren't sure what you need, take what you can get. Learn what kind of information is useful. And like everything else, iterate over this. Just because you're monitoring something up front and you find out that it has no value and you don't need it, then you can take it out later. If you find that you don't have something and you need it, then you can add that in later. So this is actually the monitoring for the system that I work on now. And you can see that it is a huge amount of stuff. And the thing is that the most valuable thing about, or the most valuable aspect to having so much stuff is that you actually just kind of learn to see the trends rather than the actual data points. So when something goes wrong, we can look at this huge amount of colorful curves and just pinpoint the one thing that is out of the ordinary, the one thing that doesn't look normal. So this is actually a Grafana dashboard that we have built. Again, I'm working on an Azure system, so this is going to be a little bit Azure-centric. But basically what this has done is we use Grafana to just take all of the Azure metrics that are available directly from the PaaS components, and we just aggregate them all into one single dashboard. So at the top, we have API requests for all of the different microservices. We have scaling information, so how the app service plans are scaling. We have per instance CPU and memory usage so that we can see the CPU and memory for each of the instances that's running when we're scaled out. We have memory stats. We have CPU stats at the service level, at the app service plan level. We have information about how many messages are going through our event queues. We have information about how all of the different collections in Cosmos DB are consuming throughput and how much of that throughput scaling is actually happening at any given time. We have information on how many Azure search queries we're getting and how much latency those are having. And of course, we also have our standard app insights and our Elastic logging. And the thing is that, yeah, this is a lot of information and it's scattered across a bunch of different places. But part of that is because we are still learning and we don't know what data is actually going to be useful at what time. So until we spend the time to build an amazing, perfect, fantastic dashboard, that isn't really going to solve many of our problems, because the thing is that we need to be able to change it. So one of the things that was on that Grafana dashboard was the per instance memory and CPU. And that came out of the fact that back when we were dealing with the app server, clicking on things that I shouldn't be clicking on. So yeah, back when we were trying to deal with that app service plan, app service not scaling correctly issue, that was how we figured out what was going on, was that we started monitoring the CPU and memory usage of the individual instances of each of those app services, and we could see that something was wrong because we weren't actually getting CPU numbers or memory spikes on the subsequent scaled out instances. And it turns out that the subsequent instances weren't starting up correctly. So by looking at those numbers, we were able to diagnose the problem. Could we take it out of the dashboard now? Probably. Most of the time, it's easier to just overlook it than it is to completely remove it, because we might have to put it back. And yeah, that is not a dashboard for operations if you have a dedicated operations team. So we have a separate dashboard that is for 24/7 support. It has different numbers on it. It has different metrics. It serves their needs. Our monitoring serves our needs as developers. And so yes, iterate over your monitoring. If you need to make changes, go ahead and make those changes. Maybe someday we'll actually integrate all of the different data sources that we have, put app insights, put our Elastic monitoring, put our Grafana dashboards, put it all together. We haven't had a need to yet because it's a nice to have. But we have made changes. The Elastic monitoring includes some extra information that we don't get out of the box from Azure. We needed some information about traffic that was coming through the gateway. And so we built a separate dashboard just to be able to aggregate that data and process it. So iterate your monitoring. And yeah, there have been a lot of DevOps cycles on my slides because reiterating over things is the key to dealing with change. So now it's time for this talk to loop back and reiterate one more time and tell you that if you test early and if you plan for change, then your cloud development project can be grounded in reality. Thank you.
Welcome all. For those of you who haven't seen me before, my name is Billy Hollis, and I started out as a developer, first writing code for money in 1978. I always liked the user design side of things, but nobody would really pay me to do that until about 15 years ago. So I made the transition. I still do get involved in development. I still do write code, but my main activity for the last 12 to 15 years has been design. Have we reached the point now, I think we have, where most teams understand the importance of UX design now? But that doesn't necessarily mean that most teams know how to do it. And I get called in often when a team has experienced a design failure to try to get something back on track. So in this session, I'm going to tell you about some of the failures I've seen, not just my own, but that I've seen in the industry, and see if we can find some common themes to failure to help you recognize the possibility that you're going in the wrong direction and give you some advice on getting you onto the correct path. So teams are still figuring out how to do design, but let's be pretty blunt about this. Developers would prefer to be doing other things for the most part. In particular, they really like writing code. And as a result, they tend to give a less attention, less than they should, to some of the other aspects of development, like architecture and UX design. So I recognize that, but sometimes failure can be extraordinarily expensive. So I try to reorient developer psychology a little bit and help them get away from their focus on code, because one of the examples of a failed design project where things went really bad and they spent lots of money was the U.S. fighter program for the F-35. They spent $1 trillion on that program. Of course, a lot of it was manufacturing, et cetera. But at the end of the day, this article came out last year, the U.S. admits that it did not fulfill its needs, and they need a new fighter generation. In other words, the article admits that they expect to throw away that $1 trillion and start over. $1 trillion. What's the economy of Norway? The yearly economy. I'm thinking it's probably somewhere in that range. Oh, I thought I took that out. So architecture, fine. We know that we can. There are good resources to do architecture. I suggest that one. I put it in the slides. But what happened to the other problems? What were the other problems in this F-35 program? Well, one of them was poor UX design, which yielded catastrophic results. In this case, that's a quote from that article that I just showed you. The fighter jet suffers from a slightly embarrassing touchscreen problem. It turns out that touchscreens in the cockpit of a fighter jet weren't nearly as good an idea as they thought it was. That the pilots reported that an unfortunately high percentage of the time, they thought they engaged a switch, a button, slider, whatever, on the touchpad, but in fact they did not. Now, why did they go to touchscreens? Well, I can imagine the meeting, although the people in it probably weren't dressed as nicely as these people, but because they're government workers, but where they said, oh, touchscreens, smartphones, that's the future. So of course we would like to have programmable touchscreen buttons in our next generation fighter. We would be able to change out interfaces and do, well, that all sounds very cool, but it turns out that it was a disaster. Because if you put yourself in the mind of the user and you think about flying, some of you may be pilots, think about the experience of needing to turn something on or off. What are the disadvantages of a touchscreen? Well, number one, you have to look at it, as opposed to a physical switch, which you can feel tactilely while you're still looking outside the plane. Secondly, it gives no substantial feedback, tactile feedback, to let you know when it's on. You have to play sound, which might be missed, or the visual, or look at it again to make sure that it is in fact engaged. So, and you think about all the distractions and such that would get in the way about that, then it's pretty clear when you look at it that way that it was not a good fit for the situation. But they spent $1 trillion without ever asking the question of whether it was a good idea. What would happen in your applications if the user thought they'd entered an order, but the software didn't think it happened? You may have run into that. That would be considered a pretty major mistake in an application, would it not? Why did they do that? Well, as I said, I'm sure there are people sitting around in a room who thought it was just a cool thing. But when I teach design classes, one of the things that I tell the people I'm teaching design is that one of the most dangerous phrases in the whole industry is, wouldn't it be cool if? Every time you hear that, you ought to be thinking, oh, this might not be good. This is a red flag. Developers love cool technology, and so they have a natural affinity to go in that direction. They want to work with it. So in many cases, they lack skepticism about it. And that leads to things like the cockpit of the F-35, which has all these touch screens. And the end result was that one of the generals in charge of this project said, oh, I have to read this because you don't drive your Ferrari to work every day. You only drive it on Sundays. This is our high-end fighter. We want to make sure we don't use it all for the low-end fight. That's a general in a press conference, a quote. Now, suppose you wrote a massive next-generation app and spent hundreds of millions of dollars on it in your organization. And it was really cool. It used the latest, best technology, but it was so clunky for everyday tasks, important tasks, that the user preferred the old system. Are you going to go to your boss and say, well, this is the Ferrari level app. It's not intended for everyday use. How far are you going to get? So what should the F-35 team have done? Well, they should have had a world-class architect. They had a bloated code base, and it was very buggy, and that's one of the other issues with it. Now, I could talk all day about too much code and code bloat and bad architecture. I'm going to focus on design here, but I don't want to minimize those problems. They needed a world-class architect, but they also needed a world-class designer who could have figured out how to make do the political maneuverings to get some good design in. Somebody should have prevented the overuse of cool stuff and aim at the intended user. But this problem is not at all restricted to projects like this. I went into a project, a failed project. They were replacing an AS400 system, and they had a modern web application, all the latest, nicest web stuff. But the bottom line was that system took longer to get an order entered than the AS400 system it replaced. Yes, the AS400 system was hard to learn. You had to memorize a lot of keys and things like that. But somebody that's sitting there whose income depends on getting these orders into the system isn't going to put up with slowing them down just because it looks better and it's cool and it's modern technology. They revolted, basically. Pounded on the table and demanded to go back to the AS400 system. And management gave in, threw away that web system, and started all over. Wasted all the money that they spent on it. That browser-based app was completely junked. Well, that's one example from my own experience of software that was created because it was supposed to be cool, supposed to be the most modern, cool stuff, but in fact didn't really meet the needs of the people it was aimed at. But it can get even worse. Sometimes there are failures because software is produced because it seems cool, and there isn't anybody that needs it or wants it. There never was. Here's the best example I know of that. You guys remember a product called Story Remix? Does that ring any bells for you? Probably not. Anybody use it? I don't see any hands. Well, it was important enough to be part of the keynote at Microsoft Build 2017. And understand that the Windows keynote at Build each year is supposed to highlight the most important innovations in Windows for that year. Well, let me show you something. Hang on. I'm going to show you a few seconds, about 20 seconds, of the video that was shown at the keynote. Let's find it. Is that it? That's it, isn't it? Yeah. Let's drag that over to where you can see it. Get it to full screen and play. This is the keynote, extracts from the keynote. Oh, we don't have sound, do we? Well, you can read the. It's kind of slow, but basically they're putting explosions into this film of a soccer game, so that when they kick the ball, it explodes, and and they were really, really proud of that too. Hang on, let me get back to the slides now. Of course, the problem going between monitors is getting your cursor right. In fact, I guess I should probably show you that that product is still buried in the Photos app today. How many of you knew that? Here, let me show you. I guess I'll put this over there so that you can see it. Where is there it is. So I have a little animation here. Some of you have seen these ideas of, oh, I've got to move it from here to over there. Hang on. Let's come here. You ever seen these reloading animations? Where they show, like, games have reloading animations, and some people did some funny ones. So that's just the video that I'm going to use as an example is the biting reload animation here. All right, let's stop that. And it comes up in the Movies app by default, so I don't need that. What I need it to come up in is the Photos app, so I will do that. Right-click, open with Photos. Whoops, come here. And of course, I have to move it over to you, to the other monitor, because it comes up here. There we are. So here's the Photos app. I'll not make it full screen, so it'll be easy to kind of move around. That ought to be big enough for you to get the idea. Now, if we go up here and you look at Edit More, add, well, they've got it pretty well buried, don't they? Add 3D effects, then it opens up this editor that allows you to put explosions in, among other things. You didn't know you had that, did you? Here, let's go over about where I need the explosion to go when the bullet hits the wall. Come on, let's drag you over a bit. Somewhere right about there, if I get it right. And drag in an explosion, like where the bullet's going to hit. Okay. And now, play the thing, and now let's go back to the beginning so you can see the explosion happen. So, yeah, see it. Now my gun is firing explosions. Who needs that? Do any of you feel like you need that in your applications? So let's shut that down then. I never did actually see it from the beginning. The Photos is being, there we go, yeah, that's kind of from the beginning you see it. Because I could put in as many explosions as I want. Wow. Isn't that cool? Well, just think about how much money they spent developing that product. And nobody cares about it. You don't care about it. I don't care about it. They buried it. I'm sure there are some middle schoolers that care about it for their class videos or whatever. So, but they spent a whole lot of money and got really nothing of consequence out of it. So, explosions in videos. I just imagine the meeting where they said, oh yeah, it would be cool if we could embed explosions in the, and notice, by the way, that the explosion followed the soccer ball. Yeah, that's upsetting. You can say, I want it to follow this object on the screen. No, it was a complete waste. So that sort of thing happens quite a lot, and the most common scenario I see in business where people do things that they think are cool is when they move to new platforms and they don't really know yet what's useful and what's not. If you were in the XAML world, which I did a lot of WPF work, it was common about 10 years ago. People used to do a lot of page flipping animations because they could. But that was the sort of thing, the first time you saw it, you might think that's cool. By the third time, it's tedious. By the 10th time, you hate it. So you have to understand that that's one of the problems with cool, is that it ages very rapidly. You get tired of it quickly. True story. I was evaluating a WPF project that a client had done, and they got to a point. I'm watching them demo their app, and they got to a point where there was a page flipping animation. And I walked up to the front of the room and pointed and said, don't do that. That's not the funny part. The funny part is everybody in the room laughed except the president of the company because it was his idea. But he took it in good stead. But you want to look at places where you have massive failure because they tried too hard to be cool. Well, there's Windows 8. I hope by now we can come to a consensus. Some people liked Windows 8, and that's fine. You do enough interesting stuff, it will appeal to some people. But it was so reviled by the user population at large that, except for a few legacy products, it's not used at all today. They just kind of quickly went past it. And Windows 10 went back to what made Windows 7 useful and popular. And there were many, many obvious design mistakes. Jakob Nielsen, one of the foremost usability and UX guys in the world, summarized them publicly. I was trying to tell Microsoft privately, but they were just sure that they had it right. I'll tell you what happened there in a moment. So Windows 8 was a failure, but it was a preventable failure because the things they were doing wrong, the design principles and such, were obviously not good design to someone who was experienced in design, which the people at Microsoft were not. They were naive about it. So that's one of the dangers as you move a team into design. And many of the failures came about because Microsoft was scared at the time. Do you realize how scared they were around the Windows 8 era? The iPad came out and had this explosive growth. And Microsoft thought, oh, that's just going to take over the computing world. And Apple's going to push us out the way we pushed IBM out back in the early 90s. So they were scared. They were really wanting to take the iPad head on, and they thought the way to do it was to be even cooler than the iPad. But the problem with that, and you know this from high school. You know somebody probably in your high school class that so desperately wanted to be cool, and they did the dress and the affectations and such. Did they turn out to be cool? Most of them, no. Trying hard to be cool is not a particularly good way to be cool. You usually fail. So if you're trying to get people to look at you and see how cool you are, you're really, that's an indicator that you're going in the wrong direction, that you're trying too hard. If you wave a flag, look at me, I'm Windows 8, I'm cool, then you're probably going to not be cool, and you're just going to irritate people. I mean, I look at Windows 8, and look at those Power Ranger colors in the tiles and the sharp edges. Now, we get to Windows 11, they've rounded out the edges in their interface now. Because, and I was in the keynote for Windows 11 when they said this. They said, we find that, our user research says that's more approachable. People like it better. Well, why didn't you do that user research in 2011 for Windows 8? Because I could have told you then. It's a standard design principle called contour bias. that people perceive rounded things as safe and sharp things as having some level of danger, which there are places where you actually use that to accentuate the danger, but on a daily basis, something somebody's using all the time, that's not what you want to do. And then there were other design problems, this monstrosity right here. I'm going to talk in a minute about why they did this, but the design principle it violated is called Hick's Law. The time to locate and use an option increases as the number of options increases. Trying to find your way through this, if it didn't have the little search thing up in the corner, it would have been so bad nobody would have used it, because you're just scanning through and they aren't well organized, and you don't have any control over how they're organized. Particularly, there are no folders. I'm going to tell you why in just a few minutes. But Hick's Law is probably the design principle that more software development teams routinely violate than any other. You finish doing a feature, you got to hook it into the system somehow. You don't think much about that. You just go stick it on a list and a menu somewhere that's already too long. So Microsoft failed to understand that. Didn't they get user feedback to find some of these things out? Because I tried talking to some of the internal people and said, I don't think this is going to fly, and here's why. Oh, well, we have talked to the users. We have showed it to them, and they love it. Do they really? Because it's violating design principles. So, and it ultimately failed. So that suggests that maybe they talked to the wrong type of users or didn't know how to do it. One of the problems that you run into when you're trying to get feedback, I call the Clever Hans effect. How many of you are aware of Clever Hans, the horse that toured Europe 100 years ago? Yeah, there's a couple of hands there. So for the rest of you who don't know about Hans, he was a horse who could do arithmetic. You would ask him, Hans, what is 3 plus 5? And he would stamp 8 times. But somebody got suspicious and started checking to see what was going on. And after investigation, what they eventually discovered was that Hans was reading the audience's body language. When he began stamping after the question, people would tense just a little bit. Will he stamp enough times? And when he stamped the right number of times, there was a slight relaxation in the audience. And that's what Hans was picking up. Now, if a horse can do it, your users can read body language and understand what you want them to say. So you have to be very careful in getting user feedback that you are doing it in a neutral fashion. You wouldn't believe seeing me in some of these sessions getting user feedback, how flat my voice is and how utterly flat my body language is, because I'm trying hard not to let them know what I like in the design. And Microsoft clearly failed to do that. In defense of them, they were still very new and learning the design discipline, the techniques for doing things. They're somewhat better today, although they still have a ways to go. But they lacked one of the essential characteristics of learning to do design well, and that is humility. Microsoft is not known for having humble people working for them. Let's talk about some other bad approaches now that we've beaten up the whole cool thing enough. Assuming a design that works well in one place will work in another. That is a not uncommon problem. Copying designs without figuring out whether or not, if we got somebody that did that.
Oh, yes. Let's do it like Apple.
Let's do it like Apple, yeah.
Scrolling effect, parallax like Apple has.
Yes.
Go for it.
That's one example. Copying something that you considered cool without consideration for whether it actually fits in the place that you're trying to put the design. And again, that comes from immaturity in design, not really understanding that most designs are created for a set of circumstances, and they might fit in other similar circumstances, but they aren't a universal solution to circumstances that are completely different. Let me tell you an example from my own experience. We did this app in 2008. This was the first really major XAML app that we did. And it was considered groundbreaking for the time. Remember, that's 14 years ago. Microsoft used it as their standard example for a business app in WPF for several years. It was designed for salesmen in temporary staffing companies. And for those users, it was considered a great design and a big success. Well, you know 3M Company, right? The people that make Post-it notes and stuff like that. They have a healthcare division, and they copied this design. Actually, thousands of people copied it because Microsoft showed it to so many people. They copied this design for an application that was to help radiologists do radiology reports. That's about as far from a temporary staffing salesman in terms of user as you could get. And to their credit, they realized this isn't working. Let's call the people that did this and come in and design for us. And we did, in fact, design their radiology app around 2010, customized for those circumstances and that user. Notice, for starters, the dark theme. Where is a radiologist operating? In a room where he's got to look at images, including some of them on, in these light boxes and such. So that just one sample screen, and that's about the only sample screen you can find on the web, because they don't like showing the design. They don't want their competitor to steal it, because it was a huge success. We did something that was a major innovation. We didn't just copy other designs like their Windows Forms version. We questioned the assumptions too. We went, okay, we're in a new world now. Are there things we can put in our design that wouldn't have been possible in the old world? That's one of the reasons you don't want to just slavishly copy old stuff. And in fact, the main thing was, you see the little picture there, that's sort of toward the bottom of that radiology report part. Up till then, radiology reports look like their ancestor, which was done on a Selectric typewriter. A lot of radiology reports were based on older systems like the AS400, and it was all just text, read or printed out. So they had an entire language to say, in the upper medial, that sort of thing, to indicate where on an image they were trying to comment. And then they would tell you what the problem was. So I asked the question in the definition meetings, is there any reason, instead of having all that verbiage to describe where this thing is, why couldn't you just grab out, most of the images are electronic now, so they're displayed on another monitor. Why can't we just get a little snapshot of what you're talking about, put it right inside the radiology report, and then go ahead and tell us what's wrong with it? You can put the upper medial whatever stuff too, that's fine. But people reading the report shouldn't have to be going back and forth with their eyes between the report and the image. And that idea caught on pretty fast. In fact, the first beta customer signed up specifically because of that feature. And they went to, I think, 400 million sales in the first 5 years that they put it out. They moved from being a second-tier unknown player to being one of the major players in that market. So don't copy old designs just because they're around. That's kind of lazy. And laziness in general is a bad design approach, but it's regrettably common. Some of you may have heard a while back, a couple of years ago, when everyone on the island of Hawaii was told that there were incoming nuclear missiles and to take shelter. Did you hear about that one? This is the screen where that drill was selected. And this is a HTML page. And the problem was that you've got the alert and you've got the drill for the alert that only goes out to the people who are being drilled. But they look almost the same. It isn't obvious which one, and somebody just picked the wrong one. But, I mean, how much thought went into designing this screen? None that I can detect, because even the verbiage is bad. The verbiage could be much improved. And I spent 5 minutes in Microsoft Word doing this, which could be dramatically improved too, but at least it would have made it much, much less likely, practically impossible, for somebody to select the real alert by accident. 5 minutes for me to do design, how long would it take one of you HTML people to implement it? I mean, I'm not very good at HTML, but I could do it in about 10 or 15 minutes. Take the old one and make it into this. Does this mean anything to you? It's a code thing. No? Well, it didn't mean anything to the security guard in the Notre Dame Cathedral when the sensor system gave an alert and said, this is what's wrong. So by the time they figured it out, the fire was out of control. So laziness is another, as I said, some of that goes back to the fact that you really rather be writing code. A theme that I will hit several times because I really need developers to understand. In this modern world, look, I know, software is extremely complex and everybody wants it out faster and it takes longer every year to get it out. And I understand the pressures that are on you. But when you use that as an excuse to create stuff that slows down users or induces them to make errors or burns down buildings, then you've kind of gone too far in concentrating on your code. But as a result of the fact that we are under a lot of these pressures and the fact that developers would rather be doing code, they tend to build what appeals to them. So for example, a lot of business apps have what is commonly known as the wall of data grids pattern. That they have main pages people use all day long, and it's nothing but like 3 data grids. The screen is sliced up into rectangles, and a data grid's put in most of them. How many of you have apps with that pattern? Come on. Now you see, I know that I should be seeing more than 10 hands, so I have to do my diagnostic routine. Some of you may have heard this. How many of you can put at least one hand over your head? Now, I will come into the audience and heal you if you have problems. Okay, so you can do it. Okay, so let me try again. How many of you have an app with the wall of data grids in some important screen? Okay, there you go. That's over half the audience now. And then we understand why people do that, right? It's another lazy approach, actually. You don't have to think much about how the users use the data to stick a data grid on the screen. It's basically the database throwing up on the screen. The schema just sort of, and people have to figure out how to use the data, and you know they can do that. That's why the data grid pattern does work at some level. But you're pushing the responsibility onto the user, thereby not worrying about how their job works at any level of detail. All you need to know is what they need to see, not how they use it. So, but data grids are rarely the most effective design pattern in modern apps because we have so many options. Still a viable way to do certain things, especially in financial industries, but they should not be used commonly. Appeals to us, exposing data needed by one user or a small number of users to all users. We have a screen. 5 of the 100 users need to see this piece of information. So we stick it on the screen for everybody, even though 95 people don't care about it. That's lazy development, but it appeals to us because we don't have to think very much about how do we make that only appear when it's needed. Forcing a browser-based app just to get easy deployment. I think the example I gave earlier of the people replacing the AS400, I asked them, well, why did you want a browser-based app? Well, it's easy deployment. Well, that's fine and all, as we say in the American South, but is the resulting app really the right fit for them? Now, they could probably have done a browser-based app. That would have been quite a lot better than the one they had. But if you're looking at things like trading apps, stock trading apps and things like that, they are almost never browser-based because native technologies are a better fit to get the kind of interaction patterns and response times that those apps demand. So I understand a lot of business apps are browser-based and it gets better every year. But doing it just because we don't want to take the time to figure out a good deployment pattern is not a particularly good approach. if you do some stuff and the users don't like it much, but the response is the users just need more training on that. No, good designs don't need much training. True story, actually, from that staffing sample I showed earlier for temporary staffing. The app it replaced required a week of training. I took that training, and I didn't understand anything about the app when I was done. And so when we pushed it out to our first beta customer, we scheduled some training. It was online because they were in another city. We sent them credentials a couple of days ahead of time. So we logged on and said, okay, we're ready to do some training. And they said, well, we don't think we need any. We have these 5 questions about the app we'd like to ask. The app was intuitive enough that they just used it. And almost exactly the same thing happened with that radiology app. They cut the training for the radiologists from a week to a day. And understand these are very high-paid professionals. And the training was reoriented to just give them tasks and have them do things in the software, do those tasks. And then if they got stuck, help them out. There wasn't any formal lecture training about things, maybe 10 minutes at the beginning. So that is achievable, even for complex things like generating radiology reports. That's achievable with good design. But if you just do what you want to do, and well, I'm going to talk about another failed approach here in a minute. So I'm starting to get into it and realize I shouldn't. So you avoid a lot of this sort of thing by vetting your designs, especially if they have radical change in them, like the touch screen issue in the fighter jets. You do prototyping and usability testing. Another technique I talk about a lot in my design classes is producing multiple designs, allowing them to be compared, letting them compete against one another. That's a powerful technique to make sure that you have an optimal design. Now, this isn't easy. Think about the fighter pilot thing. If they'd gone to the fighter pilots and said, okay, we're going to put these touch screens in, well, the fighter pilots would have said, no, we really prefer our tactile switches. Well, how do you know if they're saying that because it's right, which it did turn out to be, or just because they're attached to the past, to the way they're used to? That is a very tricky thing. Users tend to like what they're familiar with, even if it's not very good, because they've already learned it. That's called status quo bias. And the way to deal with status quo bias is to up your design to be even bolder, but also to verify and vet that the new thing is preferred by the users. And I have stories I can tell you there of design projects where they had tried and the users kept rejecting, preferring the old system, and then a well-designed from scratch system that matched their job was immediately adopted. The resistance went away because the new design fit their job and was so appealing to them. So it can be done. It's hard. Let's be honest about that. But just giving up and copying old stuff because the users are uncomfortable with new stuff is not good. Then there are various bad design approaches that I lump under the category of design theater, meaning we think or pretend that we are doing design when we're really not. And one of them is asking for feedback, but tipping off the user about the feedback you want, which that's what the Windows 8 team, the clever Hans effect. So when you go for feedback, you need to take measures to make sure it's honest and useful. One of the ways to do that is that multiple design approach that I mentioned earlier. Suppose you take one design of some new piece of your app to users and say, what do you think? And it breaks down into, well, I think that the colors aren't good, and we should switch the order of these fields. And okay, how many of you have been in that meeting? Yeah. We call that a food fight in English. Is that, you know that phrase? Why did they do that? Well, because you asked for help, but you didn't give them any good mechanism to give you help, because all they can do is either fiddle with it or say, this is horrible, start over. And most people won't do that. They've called your baby ugly if they do that. So they won't. Instead, if you do multiple designs and you put those designs in front of them and now they're comparing, which design fits my job better? and they're engaged with your ideas and your designs at a much higher level. They're expending a lot more cognitive cycles to figure out which one's better and why. And many cases, well, I like this one overall, but that one thing over there, could you find a way to integrate that into here? See, that's the kind of feedback that you want. And having multiple designs is one good way to do it. But unfortunately, sometimes even we get into this build and then get feedback. I'm going to talk about that in a minute in detail because it's design theater, really. It's not leveraging design. It's just getting to a point where the pain slightly goes away. Designing from assumptions without making sure that those assumptions apply. I've got some stuff on that. And then there's people. Have you ever had an executive come in that pretty obviously was an imposter and couldn't really carry out their job, but they covered that up with buzzwords and such? Oh yes, we are good at design. We are user-centric. They knew all the buzzwords, but they didn't really know how to do anything and make any constructive change. That's common. Designing by implementing backlog items. Granular design has its place, and every project's going to have some, but granular design means that there is no incentive or encouragement to step back and take a bigger picture of how does this fit into the design of the entire application. How do these four things fit together? Are there commonalities and such? So designing off a backlog has some, is not really design, except in a very narrow sense of doing that small piece. And then assuming that design just means making it pretty is another design theater approach. The users don't know what they want. We have to build something and show it to them. I'm indebted to the father of Visual Basic, which means he's the grandfather of Visual Studio, more or less, Alan Cooper. I was watching him in a session at Microsoft. I was speaking right after him, so I was watching him, and he said that that's just an absolute cop-out. What basically these people are saying is, I don't know how to talk to users and draw out of them enough about their jobs and what they need to design for it. It is true that users cannot design screens. That is not and should not be a part of what they do. But it is certainly possible to draw information about their jobs and their workflow out of them to do design. I know it's possible because I've been doing it since the mid-90s in my Visual Basic projects back then. So it is possible, but it's a skill. Understanding what questions to ask. When I teach my design classes, I give people a list of questions to ask users and some guidelines for how you analyze what they told you. It's a skill, and some people can develop it. Now, it's certainly true that some developers are kind of enough different psychologically from the user population that they do have difficulty building the communication to do it. So some developers aren't suited for this. But in my experience, most developers are. Yeah, so that's good. So, but again, people don't do this as much as they should because they'd really rather be writing code. In fact, I've often discussed this problem of affinity for code in terms of substance abuse. Right? I mean, you've got code heads versus coke heads. That's only one letter difference, and both of them do lines to get their fix. And some of you probably suffer from this addiction. If you're in a meeting that's supposed to take 90 minutes to discuss some functionality that you have to implement, and 10 minutes later, you're not listening anymore, you're coding the solution in your head, or even worse, on your laptop on the conference table. Okay, you understand that that's the sign of an addiction. You should be listening. Listening is another skill you should work on to do good design. And you should be able to put that aside for the 90 minutes to gain the level of understanding you need about what you're going to do. Now, but as I said, it's kind of an addiction. Developers don't like to put it aside for other things, even for small amounts of time. And the things I'm talking about never grow to be more than 10 or 15% typically of a developer's job. But boy, they resist spending that 10% on not coding. And one of the excuses they often use is, well, you know, I'm a developer. I'm no good at stuff like that. Developers often have a mental image of what a designer is that is false. And I've metaphorically shown it with this picture, which I took. I saw this flock of flamingos at if you ever go to Florida, there's a wildlife park called Homosassa Springs Wildlife Park. I took this picture there. Developers think about the designers as colorful creatures that are totally different from the turkey vultures that represent non-designers, developers, managers, etc. So that you can do it, but it's a skill that you have to develop. And as I said, one of the other excuses that they use is, well, the users don't know, we have to build and get feedback. The most common way I hear this is, we must rapidly build the MVP, and then we will iterate and refine it to a good design. I have never seen that work to get a good design. Because what happens is, you iterate until people don't hate it so much that they're bitching about it all the time. And then you stop. You don't iterate to a great design, and besides, it's very hard to get to a great design. Great design is big picture. You have to pull back to the big picture. And people who have done this and then call me, could you come in and help us with our design? Yes, let's start over and do it right. And that's not the answer they want to hear, so those people usually don't take me. Now, and as I said, look, I understand the whole MVP thing. I do. Software gets harder to develop every year. And everybody's always pushing us to get it done faster. And the entire MVP, minimum viable product, for those of you who might not be familiar, that whole thing was in response to this drive for greater speed. And I understand it. But here's the thing. A lightweight design phase, if you know what you're doing, doesn't take that long and saves so much time later that you don't lengthen the development project. You just get a higher value end product. But design expertise is sufficiently limited that in the industry that we don't really see that. How much longer have I got? 10 minutes? 12? I want some variation. 12, okay. I have to pace my last few slides to fit the time. Then I talked about designing from assumptions. This was one of the mistakes the Windows 8 team made. Remember, going up against the iPad. So they did some user research around iPad users. And one of the key findings was that the typical iPad tablet user does not understand the concept of a file hierarchy or a folder hierarchy. As in, they just don't get it. And you know people like that. Their desktop is one big, giant expanse of icons. Now, I understand that there are people like that. And out of that, Microsoft took the watch phrase, folders are where apps go to die. So they didn't put any folders in their main interface for Windows 8. But the problem they were up against is that's a bad assumption for the typical Windows user. And if you're going to push this on them, you better take them into account as well as these new people you're going after. I need to do a distracted boyfriend meme from Microsoft, going after the iPad users and leaving the Windows users behind, don't I? That just occurred to me right here on stage. So they got that wrong because they don't realize that iPad users normally are doing just consumption of stuff. Very light production of things like emails. Mostly consumption. Whereas, in the Windows world, we do work. real work. And I would hear, I hear people say when the iPad came out, oh, my grandmother loves her iPad. And my response was something like, yes, and my 3-year-old loves his Speak and Spell too, but neither of them have any work to get done. And so if you're going to aim Windows, you've got to aim it at people who are going to do work. So that was a mistake, assuming something from user research that wasn't correct. I mentioned this one in my list, that managers are especially vulnerable to this. And one of the reasons why is that well-designed apps tend to have good aesthetics. Good aesthetics is a proxy for good design to create a good first impression so that you give the design a chance. But just as men will tell you when they have a weakness for beautiful women, they'll give a beautiful woman a chance over a woman who is not so attractive. But that chance wears out pretty quickly if that person has an awful personality. So aesthetics will only get you so far. The first impression is important, and aesthetics will do that. But you can't use aesthetics to cover up a bad design. The underneath is still there and is still pretty much the same that it always was. In fact, aesthetics is only one level of design effort. Visual design overall is important and adds value. Nobody wants to use an ugly app or an ugly website. That's certainly true. But there's a limit to how much value and innovation you can do with just layout and aesthetics. There are multiple ways that you can increase the level of design effort. You can aim, for example, a design project, a small, constrained design project at a piece of an existing app. A view that people use all the time, a lot, you might do a new design for it to speed up the workflow in it, or speed up or get better data visualization in it. So a small piece of an app that's already there because you can't afford to replace the entire application. Okay, so that's a level of design above aesthetics, and it's going to generate more value. Beyond that, you might have to replace an entire application, most commonly because you're changing platforms. In which case, why wouldn't you want to do a good design and get maximum value and maximum shelf life out of it? Now, that's called interaction design. That term was coined by Alan Cooper. And that means the navigation between different views and the overall consistency and capability to handle the workflows that the user has in a proper way. I talked about the president of the company with the page flipping animation. One of the things we did there when we completely replaced their app was some surveys to find out when somebody is on the phone and you bring up the inquiry screen for a customer, what are the 3 things you expect to need to do? And we compiled a list out of that of 5 from the surveys of everybody. And the view that you get when you go into the customer inquiry and select a customer is that view, which has the most relevant data for the main things that people expect to do. And users were crazy about that. Let me tell you, they left their old app behind in a hurry because that speeded them up, helped them avoid mistakes, and the end user worked in a propane shop. Think Hank in King of the Hill, if you've seen that. So their concern was to keep their customers happy, and that design helped them do that. So overall interaction design is the next step up. Sometimes, this is rare, I've only done this about half a dozen times in the last 12 years because these are long projects. You do a complete rethinking of a workflow across a large organization that involves various aspects and maybe multiple applications. Now we've done, one of the ones I did for that in 2004, cut the labor needs for their process in half. That's the kind of impact you can have from projects like that. So you get more and more value as you go up the scale, and you should understand kind of where your project fits. And of course, as you get into the bigger projects, it's more investment, more people are involved, it takes longer, but the returns go up. So you need to kind of understand where you are in that spectrum in order to invest the right amount and have the right and set the right level of expectations and get above just the aesthetic version. Oops, I always forget that I have the arrows to point at those as I talk to them. And if you want to see some of the payback as for interaction design and the next level up, I have a spreadsheet that you can look at for that does some calculations for corporate apps particularly. And you're welcome to look at that if you like and put in your own numbers and see what you think. So let's summarize our bad design approaches. Doing no design at all, that's the Hawaii people, right? Copying a design without consideration for whether it fits, that's where 3M went wrong. Designing for the convenience of the development team, users don't know what they want. Well, yeah, but you can find out. Wouldn't it be cool if, boy, the F-35 people had that in spades, and so did Windows 8. And just various forms of design theater. Contaminating your feedback by tipping off what you want, build and then get feedback. And assuming design equals good aesthetics, which it does not. It's much bigger than that. So you can do design practices that are more durable and effective. One of the nice things about learning some of these skills and some of these techniques is that they will stay with you as technology changes. We talk in America about building a talent stack, that you know how to do various things well. You have a focus, but you can do other things well too, and that increases your value to your organizations, which hopefully eventually returns to you in the form of more money and more respect. So learning some of these things how to do these things will stick with you. Being able to learn how to work with users and focus on them. Don't focus on the technology or your convenience first. Focus on the users first. There's a time to get to the technology, but it's not at the beginning. And really learn to listen to them. You can go out and do some research. There are exercises to learn how to listen better. Do you know what the average amount of time for the average human being is when they're engaged in a conversation before their mind wanders as they're listening to someone? 2 minutes. It's less than 30 seconds. Now, you can sometimes bring it back, but you can do exercises to get that up to several minutes. Just as an example of what you can do to learn to listen. Keep asking questions. Keep testing assumptions. Oh yeah, I've got time to tell this story just barely, since we're kind of at the last slide. I was at a client, and a group called me in for a little mini design consultation. They had an app where they wanted the operator, of which there were several hundred, to ask particular questions. But the questions varied depending upon things about the particular person they're talking to. So what they wanted to do, they'd caught the data visualization bug. And so they wanted to put data visualizations to tip the user off about various things so that the user would make the right decision about what question to ask the person they were talking to. And so we spent about 30 minutes on what these things were doing and what they were trying to communicate. And then this didn't feel right to me, and after a while I realized why. I asked them the question, do you have an algorithm that will come up with the question you want them to ask? And they thought, yeah. Can you program that? Yeah. Well, why don't you just tell the user the question you want them to ask? The team had just, and the look on the face when you ask a question like this, it's just amazing. They'd never thought of that. Keep asking questions. Keep testing assumptions. Create multiple designs for every challenge. Do very deep and comprehensive evaluation to make sure that you're doing the right thing. And focus on the things that drive returns. By the way, you can get a session to talk to me about that. I do web sessions for people for free, 2 or 3 a month, that I'll talk about your business and sort of suggest some directions you can go in. And I try to find out about your business so I know where the returns will be. That's kind of my focus when I do that. So you can contact me if you'd like to do that. Also, if you want to understand a little bit about design principles, you can, I have a plural site course on that. All right, we have time for a question, maybe one question, maybe? Because we're going to lunch next, aren't we? Anybody got any burning questions? You can always come to me afterwards. Now you're all hungry. Nobody's got burning questions. All right. Well, I hope this was helpful and maybe stimulated some ideas for you. Balance out some of the code-intensive sessions that you're no doubt going to see the rest of the week. Thank you all for being here, and come up and ask questions if you'd like to.
There. Woohoo! Yeah. There are a few more seats at the front.
3.
Come on
In
in.
fact.
Come on in.
Okay.
Yeah.
Nice to see so many people.
Well,
It's full.
I can see a thing.
No,
The
I don't
light
see
is-
any people, but I see some heads.
Yeah, we know you're
And,
here. So, welcome everybody.
Welcome. Shall we
Shall we
begin?
start? Yeah, let's begin.
Right. Okay, let me try this.
By
Did that work?
It's a good start.
Welcome. Before we start with the presentation itself, I'm going to tell you some disclaimers. This presentation, most of the graphics in the presentation has been created with one of the hipster AI text-to-image solutions out there right now, Mid-Journey to be in fact concrete. So we would like some feedback on that afterwards. Also, this is the first time we are doing this presentation, so we are a bit unsure about the timing. So questions after the presentation. So I just make sure to have time.
We expect to have enough time for questions, and you are very welcome to ask them.
So before we start, just a little bit about the people standing on the scene. Me and Rune, we are from a small company called Udelt. We are 4 people, 4 security nerds doing identity, digital identity, doing API security, trust services nowadays. We are really good at OAuth and OpenID Connect, those protocols. We have been working with those for a few years now.
Quite a few, actually.
Quite a few.
Yeah.
The company is turning 10 years next year, so then we will have a party here at NDC, so everybody's invited already. Please attend.
Reserve the date. Next year. Yeah. So, my name is Rune. What to say? We have to introduce ourselves, you know. I've been programming since childhood. That's been a while now. And I'm one of those people who still love doing that. Enjoy, well, I do too much talking, too little programming nowadays, but it's still fun, and I plan to do it as long as I can. At the last years, I've been focusing very much on identity and the protocols, OAuth, OpenID Connect. And I recommend the rest of you do that as well, because it's a really interesting topic. Dag?
It is. My name is Dag Østerhagen. As the keynote speaker today, I also started doing this for money in 1997. So I've been doing it for quite a few years, also a developer, but coding less nowadays. We will get back to that. Science fiction and fancy nerd, read books all the time, games, do all the classic stuff, just do some yoga. That's also recommended for everybody, for developers. The Twitter nick is not really in use. I haven't used Twitter for 5 years, so please don't go there. All right. We are working for a company called Norsk Helsenett.
They are a big customer.
They are a big customer.
Yeah.
They own the solution we are going to talk about and do the operations on it and develop it. About 700 employees in Norway, based in Oslo, Tromsø, Trondheim. Do infrastructure, do development, do operations. In Norway, we have a separate network, separate from the internet, called the Health Network, which all health organizations in Norway have to use. It's a really interesting company in strong growth. They do have a booth in the common area. Visit them. And Simon and Fredrik, are you here? No? They are going to have a talk about Norsk Helsenett later today, 3 o'clock after this. So visit them.
Yeah, the room number 3.
Room
But
number 3.
Just out of curiosity, how many of you know of Norsk Helsenett and the Norwegian health sector? Yeah, more than half of you.
The
Go-
health
go.
sector is probably well known.
Yeah,
Hopefully.
it's something that matters for all of us.
All right. Just a short intro on the Norwegian health sector, how it's organized. In Norway, we have 4 health regions. The regions are the ones operating the hospitals, the public hospitals in Norway. Each region has its own infrastructure, its own solutions, and basically operates independent of the other regions. I'm quite proud of this. As everybody sees, the municipalities in Norway. Ish.
It will be worse, I promise.
350 of them. They also have their own health services, their own IT infrastructure, their own user directories, etc. Also, the municipalities do other stuff than health, so it's all mixed together for those. Of course, we do have the private sector, both vendors making solutions, IT solutions. We have private actors selling health services to people, etc., etc., and selling services to the public sector. And then we have the national services. Norsk Helsenett is a provider of some of them. You have Helsedirektoratet, Folkehelseinstituttet, and a lot of other actors in that area. And in addition to this, of course, we have a buttload of laws and regulations making this work. Really complex. It kind of regulates everything related to health. IT is one of the parts of it, but there's a lot of other stuff. You have GDPR, of course. We have laws for what right you as for people living in Norway have when it comes to health services. We have laws regulating how organizations providing health services should treat their data and how they should build their systems, and etc. A lot of them. So these laws equals the complicatedness. These laws basically say that Norwegian people are entitled to as a good health service as you can get. This kind of regulates how health personnel should, what kind of information they should be provided with when they are treating a patient. When they sit down with you as a patient, they should have all the correct information, all the necessary information about you for the kind of treatment you are getting. Only that, of course, nothing more, at the right time, right now, when you need it. That's okay when you are just working. Some of this information is residing in the organization the health personnel is working. In the system they are using, in their journal, a lot of information will be there. But as we saw in the previous slide, a lot of information will be somewhere else in Norway. Maybe in the same municipality, maybe in another region, maybe some completely different place. So how do you solve that? Of course, it's all about APIs. It's about providing health information using APIs. Sounds easy, right? The problem is that the laws we talked about a while ago really strictly regulate how these APIs should work. When you as an organization are sharing sensitive health information about a person with someone, you do have to know some things. You do have to know who you are sharing the person, the health personnel you are sharing the information with. That's mandatory. You also have to know which organization is that health personnel working in right now, for right now. So Helsida, which we are going to talk about today, is the lube that makes this happen, so it makes it possible. We do provide national service for authenticating users independent of where they work. We have identity providers, which basically like BankID Confidence Bypass, which uniquely identifies a person in Norway. We have built solutions for identifying organizations. Where do this person work right now? A person might work several places. It's not an easy fix for this, but we have gotten quite far along. And these capabilities we have, we provide them to APIs to use in a standardized way, using some standard protocols. Yeah.
Yeah.
I think you can bring it on.
So, Helsida has been a project going on for a very long time. It's been a political goal for at least 10 years that we should build this common functionality. So, just wanted to say a few things about the timeline of Helsida. The service was established in 2018 in November. We started very small with the limited capabilities, mainly user logon, those kind of things. And we started with a few systems that used Helsida for logon and a few APIs, very small. Then we've had, like you see in the cartoon here, at the first figure, where we have a slow linear growth. Slowly, new systems were added, new APIs were added, and things are quite fine. Then, a couple of years ago, we had a pandemic, the corona pandemic, and it was decided that everything related to handling the pandemic in Norway. We're talking about vaccination, we're talking about following up who are sick, who aren't sick, everything, all the data gathering and reporting and everything was going to be secured by Helsida, so we took off. And so we'll be going on a much steeper course from then. And from probably, maybe already this year, next year, we fear that we will start having more of an exponential growth, as in the second box in the cartoon here. We are, at that moment, we are going to secure more or less all electronic prescriptions in Norway. And everybody wants prescriptions. So we expect to take off. And we're kind of afraid of ending up in one of the two, or the bottom left graph where we take off and uncontrolled. We try to avoid that. We're not going into box number 4. The capabilities of Helsida started easy, quite simple. We identified authenticated people. But we have been adding features lately, and so now we can identify organizations, and there's more coming. At the moment, I want to say that we are running in the operations center offered by Norsk Helsenett. So we have an availability, an SLA as they call it, at 99.7%. That's the guarantee. We are going to secure some of the most critical systems in Norway, the emergency services. And they require quite much higher degree of availability. We'll come back to that. So we are aiming for at least 99.9%. That equals about an hour of downtime time in a month. And that is the worst case scenario that we are going for. And as we also come back to, we are becoming a single point of failure for everything regarding health in Norway. And that's basically what we're going to focus on from now that you know our service. Doug. But we have to explain a bit more about how things work.
Yeah. This is not a presentation about identity or the protocols or anything, but it's nice to have some background. How many people here don't know OpenID Connect or OAuth? Like nothing? Yeah, a couple, yeah. So you probably have insight in how this works. We are a classic standard OpenID Connect and OAuth 2 solution. OpenID Connect for authenticating users, OAuth for securing APIs. Nothing special about that. I won't go into detail about the flow. The main part about this figure is that we are in the middle. You have an application which needs to call an API, and to make that possible, Helside has to be there. That's the important part.
So both mentioning that both the client application, where the user logs on, has a requirement that Helside is available, but also the API. So we have dependency on both sides there. Yeah.
So we do basically what everybody else on the internet do nowadays, using those protocols. That is, we do use the specifications in themselves are very broad and fuzzy. We can choose how to do it. So we have chosen a very strict way of using these protocols. We look very closely to the finance sector, what they are doing in open banking, financial grade APIs, etc. We're very inspired by that, but we do have our own profile, which is very strict. We basically require OAuth 2.1 nowadays. So we are in the middle. So if we disappear, something will happen. Basically what will happen is that an API needing to either just authenticate the user or use an API will fail when invoking Helside. That can be really bad today. Effects today of that happening is that you maybe won't be able to get your electronic prescription, e-recept, so you have to get it on pen and paper instead. We provide information about critical info, allergies, etc. about a patient. So when you ends up at the hospital and you're going to be operated, the doctor really wants to know your allergies, so you don't get get something you shouldn't get. That information won't be available. So it's bad, but it can get worse. It will get worse in the future. Nope. Like Rune said, next year we will be protecting the emergency services. That's 113, the Norwegian version of 911 in Norway. So if Helside is unavailable, the people working, receiving the calls, won't be able to use their systems. And that can't happen in Norway. It can't happen. It can't happen. So, so we use a bit of energy on being available. The point is, we are a single point of failure, so we do have a policy that all systems providing critical health services which use Helside do need a plan B. what should you do to provide the necessary health care if Helsida is unavailable? You do have to have a plan B. Even though we have 99.99999% SLA, you do have to have an alternative. Of course, the health care the patient gets will probably be lacking. The quality won't be the same, but you do still have to be able to do the work and use your system as a health personnel. They can't fail. Right. Yeah.
Let's mention that there are some alternatives. For instance, you can have alternative logon methods. You can have emergency access to a system. You say, no, I have to access to this data, even though the system doesn't really know for sure who I am. I need this to treat a person. Treating someone is more important than information security, actually. And then you have the good old pen and paper. But you understand that neither of these are scalable, and even in the best case, they offer drastically reduced quality of the service. So how do we approach risk? How do we approach making sure that we are available? We have a couple of things that we are worried about. And don't worry too much about the size of the slices here. The topics are more important. So, the first thing that we're worried about is quality or the complexity of our own code. We are developers, we write code, we have fun doing that, you know. Lots of good ideas. Yeah, you know, things can go bad sometimes. But we are really worried about that. Complexity is maybe the biggest danger for us because we need to have control of everything. So we worry a lot about the complexity and the quality of our code. Related to that is complexity, quality, and bugs in external code, external libraries. We, like everybody else, we have external dependencies. We are built on the Microsoft .NET stack, and our service is built on Duende Identity Server. We'll come back to that as well. And apart from a couple of selected Microsoft libraries, we try to avoid any dependency at all. Of course, that can be a risk in itself, having to implement stuff on our side. So it's a balance there. But we try to have as much control of everything, all the code that's running in our service. That means we read the code. For instance, like with Identity Server, we know more or less everything that's going on there. We have read everything.
Also in the relevant parts of the code from Microsoft.
Yeah. And that's really important for us. Further on, we are worried about, I call it infrastructure in this figure. That is, we're worried about the infrastructure where we are running, errors, problems there. And also we are worried about external dependencies to external services. For instance, for a service like ours, we need to know who a person is. We need to know your name, for instance, and we need to know if a person is a health personnel. Those are national registries that we can look up. But in a naive implementation, we would have a dependency on those services to be available. We can't have that. Further on, we have other external dependencies. For instance, we consider we have a database, but that is an external dependency for us. We don't trust it. Even though if it goes down, we need to be available. And also the runtime environment at Norsk Helsenett, we really don't trust that as well. Even if they go down, we need to be available. And how do we handle that? Another thing we are worried about is incorrect use of our service. We are, seen from our point of view, we are a very simple service. We offer basically 2 APIs. But there are many ways of using them, and not necessarily a malicious user, but someone using the service wrong could potentially affect the quality of our service and our availability. So we spend a lot of time on training. Everybody who, before they are allowed to use Helsidé, we do a quality assurance of the product. And we spend a lot of time teaching people how to use the service. What you will see here is that external attackers, that's the smallest slice. We are, of course, worried about hackers, DDoS, and all that stuff, but running inside the health network in Norway, we get a lot of security for free. Norwegian Norsk Helsenett, they are very good at monitoring and operations and all that, and they handle it for us. So you see that we are kind of a special service. We do one thing and only one thing, and so we can focus on doing that very good. So this model, by the way, it has some serious consequences for how we work and how we prioritize. So you will see it later on when I go into the details. Let's talk about the technical view. How is Helsidé built? And as you see, it's simple. We really just have, yeah, but it is that simple. We have a .NET 6 host. It's a web service. And it's really a couple of APIs, mainly two, and that's it. We have some dependencies to other stuff. That's all the external registries and other things that carry data that we want to have. And then we have our database. And this is where you see that we are kind of, we're not quite the regular web app. For instance, nobody wants to use our service. There are nobody who wants, hey, we want to use Helsidé. No. They want to use Helsidé to gain access to the National Core Journal, to do electronic prescriptions. They want to have log on to their own service and so on. Nobody wants our service on its own. So we can more be considered an infrastructure component more than a service in itself. As I said, we are built on the identity server, and we are really happy about that. So we are building a service on the competence of some really, really good people. Dominic and Brock, thank you. And one thing that is special about Helsidé, I want to tell, is we call it Helsidé as a health ID for the English-speaking audience. But we don't offer an ID. You cannot log on to our service. We always use external logon. So all this other stuff in the figure, that is the bank ID, it's the bypass, smart card logon, it's other regional services for logon. So we don't even do that, but we have dependencies. Our database, we have two types of data. We have the static data, that is configurations of systems and APIs that are secured by Helsidé. And then we have runtime live data, that's mainly user sessions. When you log on to our service, we store some data in our database that we delete as soon as your session ends. And that's basically it. So we are not built for internet scale, but we are built for covering the health sector, a couple of 100,000 people. And one thing that's special about this is that health personnel, they work 24/7. They work during the night. People get sick all the time. And so we need to be available. We can't say that in the evening we can have downtime or something like that. We must always be available. But luckily, our traffic patterns are quite predictable. So our service is a very slim monolith. And this is where we get grumpy old guys don't want to build microservices because that's too much complexity. But for a service like ours, this works. It works very fine. And by keeping everything in one service, we get rid of so much complexity and so much risk. And this is probably not right for your web-based something system. But for something like Helsire, I believe it's the right choice, at least for now. So our technical design, it's mainly about handling the risk both for our own complexity, and this design allows us to have as few external dependencies as well, as few as possible. So let's talk about our development process.
Yeah.
Yeah.
So the risk model has effect on the way we do coding. What also affects the way we do coding is that when we release some new feature in test, we can probably say it won't be used in maybe half a year. The external vendors have to implement the features we release, and they have to deploy it to their customers, and it have to be taken in use in the health sector. That's a long lead time. So we do not do that much of new stuff, but we use a really long time of quality assuring it. So small steps. We are required to be never break functionality. There are thousands of applications using the stuff we have. It's really difficult to know exactly what features they're using at the time, what kind of dependencies they have. So we can't break existing stuff without giving a lead time of, say, a year or something. Then we have to be very clear about what we are doing. We do require a high people in the team, development team, do need to know what they're doing. They do need to understand the protocols. They do have to understand the digital identity topic, which is a bit fuzzy, but difficult. And they do have to understand the health sector, how it works. So it's a lot of, you do have to have a lot of skills for just starting to create code in the Helsire core. As Rune said, we have full control for our dependencies in our code, of course. We almost never include new libraries. We are also very exact about which Microsoft libraries we use. Of course, we do testing, unit tests, integration tests, automated UI tests, etc. But again, the ways of using Helsire are many. And there's a lot of combinations of using Helsire, a lot which can go wrong, which is really difficult to test in an automated way. So Rune will talk a bit about that. I see that we are 20 minutes left.
20 minutes left, yeah. So you forgot to finish your slide, but that's okay.
Sorry.
So our test environment is basically a production environment. In Helsire, we do have many test environments. We have our internal environment, we have our development environments, but we have the test environment that everybody uses. In a test environment, we have almost as much traffic as we do in production. And that's quite interesting. We have like 500,000, maybe 1 million tokens per week. So there's a lot of traffic, lots of logons, lots of systems using it. When we publish new functionality to the public, stable test environment, we expect that functionality to stay there for a long time before we migrate it to production. And this is a really good thing for us because, as Dag said, we cannot really predict all the ways, all the combinations that the health sector is using our service, all the combinations of use of our functionality. So while we do lots of testing in our test environment ourselves, we also rely on the vendors. So for instance, the National Electronic Prescription Service, they do a lot of testing in our test environment, and they give us feedback immediately when we break things. And that's a good thing.
We do suggest that vendors create automated tests against our test environment.
Yeah.
And run that all the time.
Absolutely. And having this test environment helps securing both our infrastructure and it helps assure the quality of our service in a way that we could not do on our own if we tested everything ourselves.
Right.
Yeah.
So, as we have talked about, Norsk Helsenett is kind of old school in that way that they have their own operations divisions. It's not the cloud we are talking about, which is a division and people which is it's very mature. They have been doing this for a long time. They know what they are doing. Really high level of competency. So we trust them. But they are not part of the team, the development team. It's not DevOps as is, but we work really closely together with them. In effect, they are a part of the team. We do have a couple, 3 persons who we work really closely with all the time. We talk about functionality, we talk about the processes, deploying the solution into production. Operations understand our solution really well. So, and this has been really valuable for us. I don't know if you said that, but till now, Helside as a service hasn't had any downtime until now. We have had some downtime because of other problems external to us, but nothing else. The operations teams do monitoring. We have something called Helsesert, which monitors traffic in the Norwegian health network. The firewall team in Norsk Helsenett are really good. A big IP is being used there. We have built redundancy upon redundancy. We are not on Kubernetes, so we are running classic web apps, but we are running a lot of nodes on both the internet and Helsenett. We have redundancy when it comes to the database. We have redundancy when it comes to the data warehouses. We're running in Trondheim and Oslo. We will talk more about that later a bit. And we are scaled way too high. We have too much CPU, we have too much memory, and that's on purpose. It's not expensive compared to the solution and the service and the value we deliver. Okay, we're all one. That's a good one. So back to risk model. This is the parts about external attackers and infrastructure, of course.
So our service is built to be as available as possible and as resilient as possible. So, as we said, we do not like dependencies at all. I want to talk about not dependencies on the software level, but at at the service level, we do have dependencies on external registries, for instance. And we do have a dependency on a database. And as I said, we don't trust them. Sound a grumpy old guys. That's the truth.
Nobody.
First of all, we do a lot of caching in memory at the host. So our service is built so that while we depend on a database to have both the live data and the static configuration data, if the database for some reason goes down, that could be a network outage, it could be a service outage at the database, who knows, then we know what to expect, and we will fall back to a bit lower service level where we run on cache data. We don't stop. We never stop. And that can have some consequences for our users. For instance, you might lose the single sign-on offering that we do, that you will have to log on again. But everything still works. That's an inconvenience, but it won't cause any major problems for your users. Further on, we have dependencies, as I told you about, for the national registries, both for people and for health personnel. For instance, if the registry of people go down, we still offer information about the user, but you won't get a name. That's, we have control of that. We know how to handle the situation. And the same, if we can't verify that you are a health personnel, then we still offer the information. Not everybody who would use our service needs to be health personnel. You can be administrative personnel and so on. So some systems don't require that information, some do. So if we don't have the information, we fall down to a lower level instead of stopping. We basically consider everything an external dependency. This helps us with handling risks when it comes to infrastructure, and we consider it valuable when it comes to the use of our service as well. Then we have policies. We do run a very strict security profile in Helsida. We have some very strict requirements for the systems who use our service and how they should implement Helsida. But sometimes we see that availability is more important than information security. So I'd like to talk about what we do first. We have one policy. It's quite simple. Helsida, as an OpenID Connect endpoint, we offer metadata. It tells about how we work. It tells the signing keys we use to sign the tokens and so on and so on. This data, we require that everybody cache this information for at least 24 hours. That way, if our service go down, existing access rights are still valid and can be used. An API can still validate that this system is allowed to call me, even though Helsida is down. So this is a requirement on our side. Another requirement, another effect, is that we offer a single sign-on. And we store a cookie in the web browser. So when a user has logged on to Helsida using an external identity provider, no matter who they are, we store information about that user session on our side. That means that the next time a user wants to log on to another system, they get a single sign-on, which is nice. But it also gives us the benefit that should bank ID be down, should bypass or Confidus have trouble, we already have cached that information. We know who you are. And we aren't dependent on the availability of the external providers. In addition, every logon provider, identity provider, they offer some information to us. And one of the elements is the security level. How much do we trust that information? And the security level gives the same access. If you log on using a bank ID or a smart card, it doesn't matter. You get the same access because they are on the same security level. That means that in a hospital, for instance, they often use the smart cards. If the smart card bypass service is down, they can log on using their own bank ID. And they get the same services, they can do the same thing, even though their main logon service is down. So that's cool. And then we have other policies. We have some guys building the new emergency system in Norway. And this is critical, extremely critical. We don't want them to be down. And normally we have a policy that an access right in Helside, it lives for between 1 and 10 minutes before you have to renew it. The reason is security. If someone steals that right, then they can be logged onto your system. There's no way of controlling that at the moment. But for a critical system, we allow a much longer lifetime, for instance, an hour for that access right. And that increases the risk that someone steals that access right. But they have implemented other measures that take that risk down, so we can live with it. So we do this, while we have our policies, we do stretch them to ensure availability, because availability wins.
Access right is the same as an access token.
Yeah.
You just left that out, so you shouldn't have to go into
Yeah.
what that is.
It's as a note. Don't mention tokens, because that's a rabbit hole. So these policies allow us to adjust how a service is used. And that, on one side, it prevents or helps stop external attackers. On the other side, it helps promote the correct use of our service. So,
Okay.
say a few things about the future. We're almost on time, so
Okay, I will do this quickly so we have some minutes for questions. Yeah, you should wear sunglasses.
at least if you're up here.
Yeah. We are looking into.
That's me.
That's the
Sorry.
blood sugar.
Yeah, that's my blood sugar.
Yeah.
That's one thing. If you do a talk, your blood sugar is going to the skies. That always happens.
Okay. I was talking a bit about geo-redundancy. NHN has data centers in Trondheim and Oslo. We have nodes in both places, SQL servers in both places. We are looking at also hosting a standby node of Helside in some public cloud solution, which we can switch over to in case something happens to the NHN infrastructure. We need to do the DNS stuff, of course, still, but we're looking into that. We always look at our life cycle process. How are we doing stuff from development until production? How do we work? How does it? Should we do something about it? We right now we might have some downtime if we do some breaking database changes. We're looking into finding solutions for that, being able to have 2 different versions of a system in production, having A/B testing, having control over that without using Kubernetes. And we are looking always, of course, looking at the protocols. They evolve all the time. New security hosts are found. But some of the new mechanisms we are looking into will also provide mechanisms for better availability. So looking and looking and looking all the time.
So we don't have time to go into that, unfortunately. That's okay.
So that was the last slide.
Yeah. But let's summarize.
Can you read the small letters?
But
It
let's
says
summarize.
that we love you.
Yeah, we love you all.
We love you all.
But I want to summarize. To make sure that our service is available, first of all, we move slowly, extremely slowly, small steps. But all the time, small steps. We make sure that we offer functionality that is useful. We look at what we do. We try to know what we do and try to be good at what we do. And then we are standing on the shoulders of giants. We have the identity server guys. We have the teams in Norsk Helsenet that are incredibly good at what they do. And I hope the rest of you also have a good operations team, good monitoring team, security teams, and all that, because that's really important. So,
Thank
yeah.
you,
thank
everybody.
you.
Thank you.
And we're staying here for the rest of the conference. Please come talk to us if you want. And if someone have questions,
We have
we have a
3
couple of
minutes.
yeah. No questions. That's a good sign. No, that's one.
The external attackers get to you when you have closed network?
How an external attacker will reach us, our service, when you have a closed network? That's a good question. Our service is available both on the internet and in the health network. And even the health network, while it's a closed network, it's a very large network where all hospitals, all health personnel in Norway are connected. And most of those them also have a connection to the internet. So there are ways in to our service. Luckily, we have people monitoring all the traffic, working on the firewalls, working on routing, all that. So we have lots of people who are experts on reducing the risk. And we see they are, for instance, filtering a lot of traffic all the time that would otherwise hit us. But we are available on the internet, and that's probably the greatest risk for our service.
Good question.
A question back here?
Fredrik? No.
Regarding the external attacks, one thing is like attacking you to get into your system and to steal information. But another way would be to attack you just to bring your services down. Is that something you consider, or is that like not
Yeah.
your main?
So the question is that an attacker not only might want to get into our service, but might want to just take the service down to hurt other services. Do you want to reply? Or?
Yes, we do. In that, there's something with Meyer. We do rely on Norsk Helsenet to do the DDoS thing, that part of the solution. Otherwise, as I said, our attack vectors is kind of like 2 or 3 endpoints, which we have really good control over. We do get some protection from how those endpoints are handled by identity server implementation, and we have our own stuff built on top. So we do have full control over parameters who are sent to us and how we treat them. So for volume, NHN take that bit while trying to manipulate us by doing something with the information they send us. That we take care of that.
I can also say that since we have redundancy on top of redundancy, so should someone take down a service, we can shut it down and nobody will notice anything. Should they manage to take down an entire data center, that's no problem. We automatically switch to another data center. Should things go completely to hell, then we have completely automated deployment processes, so we can up and running somewhere else in a very short time. We haven't tested that, but we're completely automated, so we can get up and running quickly.
Sorry, Fredrik, back there first. Sorry.
Yeah.
Thanks for the interesting talk. You mentioned you deploy to test and have it there for a long time before going to production, and that makes totally sense. What's a typical value for you? How long is it in testing before releasing?
How long are things available in testing before going to production?
That's a good question too.
Months.
Yeah, months.
Yeah, at least.
If there is, we are the thing when we deploy something into production, very often vendors start using that functionality. So sometimes the milestones of the vendors affect how much time we use before going into production. That was the case with Helseplattformen, for example, in the Midt-Norge right now. So it depends, kind of. We do not have a kind of strict for the deploys a year or something like that.
Yeah, so, and then
Right now,
also,
anyway.
so when things go into production, usually it can be a year, maybe several years before the functionality used even then. So we are in the health sector. We are moving slowly. I believe there was a question here first.
You mentioned unit tests and system tests,
Yes.
and that your test environments are very production-like.
Yes.
Are you using any disruptive testing in the test environment, aka the Chaos Monkey from Netflix?
No and yes, not automated, but we do run our own tests where we switch off a server, see what happens. Actually, next week, we're going to do that in one of our private environments, our QA environment. We're just going to shut down and just to verify that we don't have an interruption in our service while we switch over to another data center. If that goes well, we're going to run the same test in our test environment and maybe in production. I don't know if we dare. But we don't do like automated with the Chaos Monkey and all that. I don't think the Energy and Norsk Helsenett operations team would be too happy about that. Do we have time for one more question?
Yes.
Yeah.
There was.
Just a remark, 113 will run just fine without Helside.
Yeah, that's an important point.
Yeah, that your service, they are running, then they're building the emergency services that are replacing the existing system, and they will run just fine even if we go down. But it won't be fun, will it? You have to redeploy, and your users won't be happy. They won't get the national emergency information, so you can still help people, but the quality will be reduced. Anything else?
All right.
Good. Thank you very much for being here.
It was a pleasure.
One more thing. In room number 3, in 4 minutes, go and listen to Fredrik. 20 minutes. Yeah, 20 minutes.
20 minutes.
Yeah.
Yet. Well, I guess the microphone's working. Whee! This is a good start. Hello, everybody. My name's David, and I probably shouldn't be here. You definitely shouldn't. Yes, these things work better if I press the button on the right screen. There we go. Who here loves form controls? Yeah, it's fair enough, really. They're not exactly the most exciting thing in the world, but you can do some interesting things with them. So let's see where we go with that. Let's write some code that's embedded in another site, and you can't see it because there's like cross-site protections and stuff, so that doesn't work, does it? So we're going to open a browser window, and everything's going to be fine. Be calm, David. Everything's just great. Because I prepped all of this. I didn't prep any of it. I've been far too busy. But the good news is that I have done this talk before of a form. So there's nothing shockingly new here that's going to freak me out, I hope. But we'll see how we go. It should be good, I reckon. I'm going to work out what I'm doing and remember what I'm saying. And that's better. Right, we get a slightly better view. Form controls, they don't do a lot. They're very dull. But you can muck about with them. There's a thing called the checkbox label hack. Some people have argued with me that it's not a hack at all. I say, well, it's not doing what the thing was originally designed for, and we're using it to make it do something else, so that's a hack, right? Anything that takes one thing that's supposed to do A, and we make it do B, that's a hack, right? Anybody down with that? Anybody disagree? Good. I don't have to shout, get the fuck out at anyone. This is good. So the checkbox label hack utilizes some of the lovely features of CSS that everybody loves so much, because CSS is a wonderful, popular thing. And we're going to actually just set this to SCSS SAS, just because it will mean we can write some slightly shorter code. We're going to create a checkbox. Thrilling stuff. Input. Type equals, people can't type when you're looking. No, I can't type when people are looking. Also when my fingers are shaking, because this is all fine. Type equals checkbox. Isn't that exciting? Right, we have a, no, there it is. Oh, you can click on it, and it clicks. And then, how exciting. Now, of course, you can give that a label. Ordinary thing to do. We're going to put a label in. Yeah, we can spell that as well. Yeah, great. And we wrap it in there, and that's the right way to do things. Everybody's agree with that? You know, it's so simple. We don't have to use any like for attributes or anything. It knows which is for. It's in the middle of it. That's not very helpful though, so we're not going to do that because all will be revealed in a moment. We're going to have to give this an ID so that it will work, and we're going to call it CB1. Why not? And then we're going to give it a label, and we say it's for. Equals, yeah, CB1, thrilling. Oh my God, can you believe how much fun we're having? This is amazing. And the label probably better say something, so we'll call it, okay, so label. Oh, phew. I mean, this is just top level stuff. It's properly exciting. And now we've got a label. And because the label is associated with the tag, look, clicking on the label, oh wow, this is magic. I've never seen anything like it. It's just blowing my mind. Everything's fine. What we do know about checkboxes is they're ugly, and that you can't style them. And I'm sure lots of you know how we get around that. But for those of you who don't, we're going to explain that in the CSS. We're going to create a rule for some inputs, right? We're going to have input, we're going to go type equals checkbox. Why not? Seems a good idea. Great. We are going to say, hello, Mr. Checkbox, would you kindly piss off? Because nobody wants to look at an ugly checkbox, do they? So the checkbox is gone. But we're left with a label, and that label controls the checkbox, even though you can't see the checkbox. So now we can style the label. Whoa, that's amazing. But we also kind of want to do funky things. We want to have extra abilities. We're going to leverage the ability of CSS to do extra bits on the outside, right? How am I going to do this? Right, we're going to go, and because we're doing a bit of SAS here, we can do some nesting and stuff. Isn't that groovy? And so we're saying this is a checkbox. If it's immediately followed by a label, these rules are going to apply. And then we're going to give it some stars, shall we? Let's do that, right? Right, this is where I am going to hack into the matrix, right? Download Neo's abilities. This is great, right? I'm going to type so fast you can't even see it. But, oh, we seem to be back. Okay. Coder sound check, 0, 1, 0, 1. One person. I hate you people. Okay. Let's see, these size can come down just a little bit. So there we go. We've styled the label. That's very exciting. But now we want to style. We need a new checkbox, basically. So we're going to style that, and yeah. And we'll just drop some code in there, because obviously I prepared one earlier, and we are indeed copy and pasting. I lied to you before about the matrix. I'm so sorry. So yeah, now we should have that. Why is that not working? Because I popped it in the wrong place. Right? Undo that. It should be. No, that is the right place. Label with before and after. Yeah, it should be there. How's that working? I need something. It's there. Yeah, it might be that there's something that goes on for a additional one that's specifically for the before. Okay, there we go. Everything's under control. Whoops, no, that broke the code. We don't want that. There we go. Should get a grey box now. Hey, well, it's great radio. Right. Doesn't matter. Who cares about the styling? So we've used a bit of style on the before, and we said, right, there's a thing there. Now it looks, and we can make it change, and we can make it do nice things and look lovely, and that's all very, very exciting. And then we need to obviously have a style for when we actually use it. One of the nice things about CSS is that it is aware of context as far as form controls go, because it knows whether radios and inputs are checked or not. So we can say, well, that's some great layout. That's really meaningful. Great. You say, if it's checked and it has a label after it, then make the after bit differently styled. Whoa, we've got a style check. Oh my God. It's thrilling, isn't it? Didn't even use JavaScript. Amazing. Okay, this is pretty basic. It's not that impressive. But really, what's the point? Well, you know, there's some power here. There's some basic logic that you're doing in CSS. So you can start to build some other things. Seems we've lost a bit of time. This might be an excuse for me to just go and find a bit of old code and just chuck that up on the screen instead of building it in front of you, because honestly, you might get a little bit bored. Although I hope not. That would be very unfortunate. Can I remember the shortcut to change that? That's great. Superb. Let's have a look at this. See what we've got here. Ooh. Oh, fine, it'll do. Just replace the window. Don't give a damn. So we've got some tabs. How do you build tabs? You go get a library, don't you? And it's got some JavaScript in it, and you click that, and that happens. You click that, and that happens. Oh, it's exciting. Okay, so let's have some tabs. Right, there we go. Fully functional tabs. Have a look at the JavaScript column. Now give me a round of applause, please. It's all the same stuff. All we've done here is we've used checkboxes with labels and a little bit of CSS to control whether things are displayed depending on the state of the checkbox. It's just amazing. You didn't think you could do that? Look at that. There we go. There's some really basic HTML, nothing funky there. And then some really simple, well, actually, this stuff goes through steps because originally I did it chunk by chunk. But, you know, this is how much that grayed out bit, that's the whole thing. That's all it takes. It's kind of amazing. Let's have a look at something else then, shall we? Oh, this one's good. Right? Why don't we have this one? Right. Let's get that to go away. And bring this one to the stage. Very exciting. There we go. Oh, I'm saying that's probably a little bit too big to really be visible. Everyone read that? No? Oh, that's unfortunate. Doesn't really matter. Can you see the bit at the bottom is the important bit? Because what we've got here are collapsible accordions. Exciting, right? Look at this one. It even knows which one to be open and which one not. Anyone want to take a guess why? What's controlling the logic? Radio buttons, exactly. Only one radio button can be true at once in a set. Boom, sorted. Same code. Basically, the same thing has been reused over and over again. What's the point of all that, really? Well, essentially, it's not really about the CSS, is it? It's not really about building these specific things, or even necessarily about any specific other thing that you could build with it. But think about the tools that you have at your advantage, and what is the minimum level of tooling you need to actually build something that is complex and interactive that you would normally have to go off and pile in loads more tools, throw in some JavaScript, throw in some frameworks, throw in a library. You don't need them half the time. There's a lot that can be done, which is really good fun. There's one more that I want to show you, because these have been kind of ugly. I'm going to go back a little bit in terms of what we were doing. Chunky buttons, oh, that's really boring. Okay, where's it gone? Should be here. Okay. Whilst I try and find that, I want to literally got paid to build this. Can't believe it. Amazing. Completely irrelevant though, because that actually uses JavaScript. Not very much. The point is you use as little as possible, wherever you can. Oh, I had a really nice slider button somewhere. Well, doesn't matter. We can live without that. That's it. There's all the stuff about code, really. And we're like quarter of an hour in. That's probably reasonably healthy. Where do we go from there? I think we go. See, there's loads more slides. One slide for every demo that didn't work. And then oh my God, how many of them were there? Here we go. This is a screenshot, basically, of a website. There's a little thing called Cylon. I have permission from the chap who built it to use this in the talks, because it's really goddamn cool. You see what it says there? Logic gates and adders in pure CSS. Logic gates. Anybody not know what logic gates are? A few people. Okay, so logic gates are basically your foundational components of all electronics, both physical electronics and our software, hardware electronics, the things that we build computers from. Logic gate basically takes one or more inputs and decides what to do with it. So let's say you've got two inputs, got two lines of power, right? Actual electricity, they go into a logic gate. And the logic gate decides what comes out the other side. Say it's an AND gate. The AND gate says both of those circuits need to be turned on before the output circuit is turned on. Lots more complicated, different versions. You've got OR gates, one or the other, which exclusive OR gates, only one or the other, and there's loads of them. You build all those up, simple little blocks. Build loads of simple blocks together, and you start getting quite complex stuff. You carry on doing that, and you get stuff that's so complex that we've actually got computers. And you carry on doing that and mucking about with some more, and you get all this machine learning stuff, and people saying, it's AI, it's not. But they start doing insane things. And it's basically all just logic gates. So the thing is, in principle, if you can build a logic gate in CSS, you could build a lot of logic gates in CSS. All right, let's not get ahead of ourselves. Let's have a look at some logic gates. Come on, open. Did that open? Ah, no, it didn't open. Right. Copy the link. That's oh no, that's a link to logic gates. No, that's a oh, yeah, okay. Oh look, this actually works in the screen. Oh, amazing. I don't remember how I did that. So that's really groovy. So this is an AND gate. First one here. Turn on that input, as we just described earlier. Turn on that input, oof, and it lights up at the bottom. It's magic. Power of logic. An OR gate, that one's on. Oh, it turns on. That one's on. Turns on. That one's on. Oh, both of them on. Oh, it's on. Woo! Vodka, please. Anyone? Aquavit. I'm not picky. Well, let's turn that off. Right. The exclusive OR gate I mentioned earlier is like an OR gate, but it's exclusive. You've got to have both, one or the other, not both. Right, it just won't be happy. It's a monogamous gate, I suppose you could say. And that's kind of exciting stuff. It's all just pure CSS. All right, let's have a look at what else we got here. Half adder. Add 2 binary digits, right? Familiar, zeros, ones, binaries, on, off, that's all it is. And you can combine the outputs of those digits and have complicated outputs by combining your logic gates. And that's pretty impressive stuff. Remember, we're all purely in CSS here. There's no JavaScript whatsoever. Good. Glad you're so impressed. Look at that one. My brain melts trying to think about how you put that together. And then I remember you just take simple things and you add them together step by step, and you end up with complexity. It's pretty cool. So here we go. We've got 3 channels. Who knows how to count in binary? I love this bit. So I had a cheat, a massive, massive cheat. I was very, very young, before I even went to school. My father, who he was in computers quite a long time ago. He worked on the Juice. It was the size of a house. Absolutely insane. He taught me ABCs, taught me how to count, and then he taught me to count in binary. Such a useful skill. I used it all the way through school. It got me beaten up. Yep, that's it. Try not to put the water on top of the electronics. Seems like a good idea. So, yes, Rendell? That's good. Unfortunately, we didn't have any beer at school. What's the education system coming to? Okay, so binary is a counting system. We're all familiar with decimal. In the decimal counting system, each column represents a number of tens. You got singles and things. We know that, right? Binary, each column is a number of twos, which is just fantastic for making poo jokes. That one didn't go down well. The binary column order is reversed for reasons we don't really want to go into, but our first column, which is on the, from which way are you looking at it? Which is on the right-hand side. Sidebar, when I try and remember which is my left and right, I actually have to go back to the little lane outside the primary school and remember turning on my bicycle when I first learned what my left and right was, because sometimes I forget, and that's the only way to remember. Why did I tell you that? So, the rightmost column. What would be the leftmost column would be our ones. This is our first column. The column of ones, we count on that. There's 1 in the ones column, and that's a 1. Put more in the ones column means no, you can't. I'm sorry, it's binary. We've only got 0 and 1, so you can't go higher than that. So we need to move on to the next column. The next column, we put 1 in the next column. The next column is 1 to the power of 1. And so that is 2s. So you got 1 in that column, that's a 2, right? You with me so far? This is good. All right, anybody want to guess what happens when I click on this one? What would the number be? 4. 1, 2, 4. Next column is going to be, and then. Oh, no, come on. Say that one again. 128. You hear that a lot, don't you? What's the next one? Wow, you hear that one a lot as well. Where do we go after that? Oh, before you know it, it's 1024 and 2048. Oh, I've heard all these numbers before. Why is it we use all these numbers? Oh, that's why. That's literally why these numbers are so important in maths and computing, because between hexadecimal and which is 16, 16 being a number that is obviously quite important in binary because it's 4 columns, these are the things that control the basic numbers and the reasons why we use them. So what we see here then is a 3-column adder that outputs the bottom. There we go. So we got a maximum possible value, 4 plus 2 plus 1, so that adds up to 7. Only need 2 columns to display it. We link an XOR, an XOR, an AND, and an OR. Put 1 in that column, and we got 1. Put 1 in both in that column, we've got 2. Oh, God, don't double-click things, David. Come on, get that right. Right. And then put them all together, and hang on. 0, 1, 2, 3. That should be 7. Why is that coming out? I don't know. All just ones. And then hey, yeah, you know what? You're right. Oh, I'm glad you're here. Yeah. It's been a long time since I've done this talk. Please forgive me. That's pretty cool. That's pretty cool. Shit the bed. Oh my God. Oh. 4 full adders change to get them to 2-digit binary numbers, not 15. So 5-digit binary number. And oh my Lord, it's pretty though, isn't it? What does that look like though? A circuit diagram. And do you know why? It's because it's what it is. We're building circuits. We've got logic gates and circuits. It's all done in CSS and HTML, and that's quite impressive. And you take some of those and you put them together and you add some more and it gets really complex. Then you could end up, oh, wait, no. I said we're not going to go there. We don't know. Jesus Christ. How are we doing? Oh, could be worse. Ah, look at this. Nothing to do with logic gates. This is actually a really cool thing. What this does, I don't know how he's done it. It adds up binary numbers, and then it outputs them in decimal below, and it's all done in CSS. Who wants to play some binary games? Kill me now. All right. So we got 1s, 2s, 4s, 8s, and 16s. That means we can go up to a total of, in one row, anyone want to hazard a guess there? 31. Excellent. And we've got another row below that, goes up to the same, which gives us a maximum total of, go on, whisper it. Yeah, 62. 31 plus 31 is 62. You are the best. You are just great. I love you. Alrighty. Somebody give me a number between 0 and 31. 26. You got there first. I kind of feel like this is kind of mean, isn't it? So 26, what's that made up of? That's the largest thing in it is a 16, right? So we can fit a 16 in there. Look at that. Do you see that cool effect? Oh, man. I wish I had a marquee and a spinning GIF of under construction. That would be really cool. That leaves us with 10. The largest thing in 10 is an 8, so let's stick one of those in there. And that leaves us with 2. Let's stick in a 2. And oh, there we go. 26. That's how you build 26 in binary. That's an interesting reverse way to think about it, how you construct these things. I quite like doing it like that because it's really simple. And you know, you can introduce kids to it like that because it's just take away a bit, and just deal with what's left. All right, let's give it another one. Done. 0 to 31. Sorry? 17. All right. Would you like to come up on stage, sir? Go on. I've got time to kill. I'm trying to fill here. All right. 17. What's the largest binary column that's available in that? 16, correct? Which leaves a remainder of, which fits very nicely into, and there's your answer. So close. You guys were so close. You nearly got 42. Thanks for trying. It's good effort. Fantastic stuff. Right. This is the bit where I'm slightly concerned. Because I kind of worked this out earlier. And we're genuinely going to do a live code experiment. And oh, God, I'm an idiot. Oh, I've got some notes, though. It's okay. Everything's going to be fine. You can get rid of that. Where's the other one gone? All right, let's have a new one. Code pen. This is so different to any other time I've done this talk. Last time I did it was what was previously a half-hour talk. I did it in 15 minutes to an audience of non-technical people at a rate of knots. And it was incredibly good fun. And you just, after doing something like that, you just come off, you're just buzzing. It's like, oh my God, it's amazing. I've got to have a drink to calm down. It's all good. It's all good. Right. So we're going to want to have some inputs. And we're going to need an output. So here we go. Start with the checkbox. Oh, there it goes. That's updated eventually. Took your time. We're going to need to style that. We've seen all this before. It's not terribly exciting, is it? Where do we go to? Right. Let's just take all that styling and jump in. We don't need to go through all the details of it. We'll just run through it very quickly. So radios and checkboxes, we hide. If we've got a label next to them, we style that label. And then with the before and after pseudo elements, put some basic styles on it. Always remember to put in empty content. If you don't have that in there, you won't see the damn thing. And if you forget about it and you don't find the answer, you could be looking for it for a very long time. And then a bit of basic styling on the color. So that's great. And if it's checked, we give it a bit more styling so we can tell the difference. Superb. That should have updated. And it hasn't. Ah, SAS, well done. Thank you very much. Excellent. Right, audience participation is great. I appreciate your support. I clearly really need it. Superb. Bang. That worked. Magic. All right, so we're going to need another one of those. I'm going to have another input. How do you build things? Mystery, mystery, mystery. There you go. Got two inputs. We should have very shortly. That's very exciting. And we need to have an output as well. Right. So now we have to do the complicated magic, the really, really complex bit. How do we turn these three checkboxes that just sat there next to each other into a logic gate? This is going to be tough, right? You're going to, at the end of this, you're going to be like, wow, that must have taken you like years and years. And to be fair, like, you know, it's quite a lot of learning and education over the total. But the actual final solution, oh God, I'm Jewish, right? It's okay. Slava Ukraini, everything's fine. Whoops. What we need to work out then is what happens, right? Well, we need some way initially to determine the state of our output. And we don't really want it to look just like a checkbox, because then you can't really tell what's going on. So what we're going to do, let's say if we have an input that is followed by a label, and then followed by another input, and then another label, and then another input, because we've got three, right? You're following me so far. It's fairly straightforward. Another input, and another label. The pseudo element after, which is the one we're using for the background, let's just turn that red, right? Because it's off, right? Nothing works at the moment. Exciting. Why did that break the... I don't care, but how did that affect the border radius? Oh yeah, that's why people hate CSS. I get it. Okay. So let's have a look at that rule again. We're going to copy that across. And what we need is for it to turn green, because that's going to tell us it's on, right? 0C0, isn't it? Yep. RGB. Look at that. I can remember 3 letters. Honestly, it feels quite impressive to even be able to remember 3 letters right now. And we need to work out how this logic is going to work. So this is a live coding experiment with all of you as audience participation members. Shit. Does anybody want to have a guess at what we have to do to this line here, line 49, to make the magic happen? And if you do know logic gates, And if you do know how to do this kind of thing in CSS, maybe keep it to yourself, let someone else have a go. Don't all rush up at once. Anyone? Yes? Okay, that's a good start. Remember, we're doing, all of our controls are based on having the checked property, which we can add to any given input with colon checked after it. So, in that list, we have 2 that are our inputs, our input inputs. God, the naming convention is so convenient, isn't it? I had a joke about naming conventions earlier, but I've forgotten it. Never mind. All right, well, it's pretty obvious, isn't it? It's the first, well, maybe it's not. We'll find out. The first 2 are the first 2. So if we say when those 2 are both checked, then, oh, that's a country, mate. That's not a, never mind. Oh, my God. I'm fine. I'm not panicking internally. There we go. Okay, so when they're both checked, then the label should be red. Okay? Okay, that's good. All right. Doesn't work, does it? Oh. The label should be green when they're both checked. Oh my God, it does work. Oh my God, we've made a logic gate. Woo! You tried. That's pretty cool, man. I didn't realize we were watching cricket here. I'm hearing crickets. That's a different matter. Right, this is all good. Okay, so I worked that out earlier. It was pretty easy. I spent days worrying about it. Oh, where am I going to do this? How does it work? Whatever. The moment I actually sat down and tried to code it, well, not the first moment I sat down and tried to code it. Did try and sit down and code it last night after geek drinks with a bottle of tequila in my hand. And guess what? Didn't work. But 5 minutes this morning worked out. Obviously, I have slight advantage. I kind of have, in theory, some idea what I'm doing here. Would anybody like to hazard a guess at making an OR gate? So remember, an OR gate works if one of the inputs is on, or the other input is on, or both of them is on. Anybody want to have a guess, or shall I just walk you through it like sheep? 2 CSS rules, good start. What's the difference between them? Because if they're the same CSS rule, there's got to be a difference, otherwise there's no point, right? Piss off, Rendell, you clever swat. Teacher's pet. There we go. All right, should we see if it works? It's going to be so funny if it doesn't. I'm going to beat the shit out of them. It's on. Okay, all right, let's turn it. No, it's on. And if they're both on? Props to Rendell, well done. Thank you very much. So one of the other basic ones we mentioned earlier was the exclusive OR, an XOR gate. The difference there is if both of them are on, won't have it, right? It's the monogamous gate, remember? So we're going to have to make a little change here. Anybody who isn't Rendell want to have a guess at that? Sorry, say again? I can guarantee you it's simpler than that. But it's good. Hmm? Yeah. And how would you use that?
One is checked, the other is not checked. And then the second rule is the first one is not checked, and the second one is checked.
So, what you're saying, I think, is just do this.
Not checked.
Yeah, you're right, not checked. Does that work? Does it need brackets? I can't remember. Yeah, all right, let's try brackets. Oh, it went green. I like that. Nice color. Oh, syntax highlighting is the best. Look at that. We've just built 3 different types of logic gate in HTML and pure CSS, live, on stage, with your assistance. Well done to all of you, apart from the ones who didn't help. Logic gates, amazing. So, like, these incredibly simple tools, once again, this isn't even much complexity, is it? And we built a foundational component of the modern electronic and digital world. That's pretty impressive. It's pretty impressive stuff indeed. How are we doing? Oh, not too bad. This whole section hadn't really been timed. And when I built that little one earlier this morning, I was like, yeah, this is going to take, oh my God, that's only going to fill about 5 minutes. And I need about 20. God damn it. But we've done all right. We've done all right. I think we spent about 15 doing this. You know, timing's been good. Let's see if we can get back to my slideshow somehow. Somewhere around here. There's a slideshow. Oh, that's great. The only problem with this one, oh, didn't want to do that, is I think this page actually breaks the directional stuff. Ah, yes. Rendell, help me out here. How do we turn this into profit?
Venture capital.
Fucking sweet. Yep, get that sweet, sweet unicorn money. But I don't mean the venture capitalist. I mean the unicorn that I'm going to buy so I can recreate this scene, reshoot my own GIF, and send it to all of you. So that's some cool stuff. I quite enjoyed that. There we go. There's my talk. I'm hoping you've got a lot of questions because we've got quite a lot of time to fill. Thank you all very much. I have to give due credit to my dearly departed father, to my good and absolutely insane Eddie Timon. He got this like how to HTML book at me and was like, you could do that. You could be a webmaster. And it's a stupid idea. Within a year I was. The wonderfully behatted Dylan Beattie, who first prompted me to put together an early version of this talk 5 years ago for Full Stack Conference in London, which was such an enjoyable experience, I didn't do it again for another 5 years. To all at Team NDC for organising this, oh my God, mind-blowing conference. That conference floor is just amazing. Look at the food. I haven't looked at any of the tech stuff. I'm just like, look at the food. And of course, for being such a wonderful and forgiving audience, and for turning up in the first place in these numbers, I am blown away, honestly, absolutely amazing. We need to update that. There's the original thanks. All due credit, right, if you're of an age, you know what this t-shirt means, made by the absolutely amazing Amy Danielle Dansby, who is a legend in her own right. So thank her very much for providing the most appropriate torso covering for this event. And to Glenn, who... not knowing what he was getting himself in for, encouraged me to actually put together my pitch and put this whole thing on, which is nice. So I'm me. You can find me there. I highly recommend you don't. You can also look at other things there. It's probably not worth it. Thank you all. We shall open to Q&A in just a moment. Excellent. And answer to your first question, no, I don't know why I'm such an idiot. Yeah, do we have anybody who wants to... Is that a hand, or are you just taking photos of me so you can make fun of me for all your friends on Twitter? That would have worked a lot better if I hadn't stammered. Wait, are people leaving already? Good call. Gentlemen at the front, please. Just wait a second, we've got a microphone coming round for you.
Does this work in emails?
That's your answer. You're not getting any more than that. Yeah, CSS supported emails is an absolute shit show and has been for years. You probably can now, actually, because there's an awful lot that somehow people are doing dynamic emails, and I don't know how, and that's because I refuse to find out. Look, everybody's probably got to do a little bit of time at some point in their career styling an email. But once you've done it, you never have to do it again, and you get to tell people to fuck off if they ask you. It's great getting older. Sorry? Code of what? Never heard of it. Right. Any more? Joe? Oh, that's convenient. Saves some time.
Look at that. For your... I like the accordion. That's nice.
Thanks.
Are there accessibility implications there?
Yeah.
How might
There
we
are.
fix
The
them?
accessibility implications are, it's so simple, you don't really have to worry about it. It's using the most basic tools there are. So it's the big problem is you come along, you do something fancy, you add in a load of things, you a bunch of elements that aren't doing what elements are supposed to do. All of these things are doing what they are supposed to do. A label is clickable. It should be clickable. Superb. Who cares if I make it big and long and take up the whole top of an accordion? It's wonderful.
Some people with screen readers might care.
Still got text on it. What's the problem with that? You've got to label your labels because otherwise nobody knows what they're for. That works, doesn't it?
Well, if you're maybe this isn't the right forum to have an argument. If you're filling it,
Oh yes, it is. We've got time to kill.
right, outside.
Now.
If you're filling it with a whole bunch of copies, say whatever is in your nice accordion, your screen reader is going to read that out as if it's some sort of selection that they can make between the various bits of content. So you might want to use ARIA labels to make it obvious what's going on the
Yeah, that's true. I mean, it doesn't take an awful lot. I mean, that's everybody does ARIA labels as standard, right? Right? Yeah. I mean, honestly, it depends on where your baseline is, right? This stuff is as standard for what I build as far as possible. So often I don't really think about it and call it out, but you're absolutely right. You do need to make sure that those little details are there, but it is easily done. Question over? If you're prepared to yield.
Never!
Thank you.
Could you raise your hand?
Somebody sing a song while we're waiting. Whistle a jaunty tune. Oh, over there. Excellent. Hello, sir.
Yes. So another accessibility concern was the first one you showed, the checkboxes. So I see that you have done a quick thing now. However, using display none on the checkbox, I think that removes the tabbable, makes the input not tabbable. So you should use something like SR only or visually hidden or whatever they're called now.
Yes, you're quite right. Yeah. Visually hidden will make all the difference to screen readers. You're absolutely right on that one. Well spotted. Any more for any more? Well, I mean, it's a start, isn't it? We've had fun. Well, I've had fun. Panic attacks and all kinds of things. Actually, this is pretty much on time, so we need some time to change over from the next person to get ready, presuming there is someone coming after me and everyone hasn't just looked at this, given up and gone home. Because really, they're not going to get better. No, they're just like, it's over now, you've ruined it, Dave. Stop it. Thank you again for attending. I hope you found it informative. If you'd like to chat about it in a less brightly lit public setting, you can always come and find me. I should be fairly locatable at any given time, thanks to genetic freakishly long legs and the Mohican is not genetic. That was a choice. Thanks again. Enjoy the rest of your NDC Oslo. It has been a blinder. Cheers.
hopefully. Cool. So, hello everyone. It's great to be here in NDC. First time NDC for me. First time Oslo as well. So it's amazing to be here. As you probably know, we're here to discuss about some web performance APIs for both monitoring and improving the performance of your app. And this is me. You can find me on the web as Whitey Combinator. I'm now an engineer at Medallia doing front-end stuff. And I'm a mentor at Tech Labs. By the way, who's here doing front-end, working with front-end or cool? Yeah, just one. Yeah, quite a few as expected. So before we start, I do have a couple disclaimers. So the first one is that whenever something sounds like a lot of content or really deep, check this emoji. It means we can have further discussions after the session. The second thing is I know that 60 minutes is a lot of time, so it might get boring sometimes, but I'll try my best not to, using memes and demos. And the last thing is that I have to give it up for Zeno, because the idea for this title of this talk is from his session from back 2016, where he was going through some new stuff in HTML. So yeah. So a bit of the whys behind of the session. So I'd like to go from this into, okay, let's first discuss what we already know. So we already know, for example, that we have HTTP2. It brings like multiplexing and the push API and a lot of other interesting stuff. We know we should compress JavaScript most of the time, which is it, but we also have alternatives like Broadly, and people keep building more interesting ways to do that. We also know that image CDNs are a good idea. There are even some researches, mostly by Google, where they show that you can reduce from 40 to 80% the amount of the size of your images if you serve them via CDN. Plus, it saves you a lot of work, for example, transforming images and manipulating that. We also know we should try to optimize the third-party scripts in our app. So, for example, first we can defer loading them, but we can also replace. We know that we can, for example, replace Lodash with like smaller libs, Moment.js with date FNS or other smaller alternatives. We can also update some of the libraries. So React is one example of library that each major, the bundle size gets smaller and smaller. There's the PRPL pattern out there that is, you probably heard Google speaking a lot about that. And if we have some, I don't know, really heavy work happening on the main thread, we can offload that to workers. That's one thing we can also do. We know about bundle splitting, probably. So if we have a huge bundle that's going to take a lot to download and to be parsed by the VM in the browser, we can split that into smaller chunks. And then we get to something like that. And if we do bundle split, we can also have dynamic imports and basically, for example, save users from downloading things in the browser that they might not end up using. We also, last but not least, we have list virtualization, which is something really interesting when we have like lots of content to render in the browser. So if we do that, we are, for example, sparing from doing a lot of things in the DOM, and we render only what's visible. So, but yeah, we're doing these, like at least most of them, right? About 4 years ago, I had a similar session where I spoke about some of these items, and it was in 2018. So it's some of the things like people were already doing back then, but I constantly see myself facing some realities of the industry we work on. And to show you that, I have this map. It's basically some statistic data of people accessing our app across the globe. And in some parts of the world, like US and Europe, we have good numbers, but we have some parts of the world where we have like red, or and then the good ones. So it's like I constantly face this kind of problem happening, and this brings me back to this. So that is the problem of fixing web performance, because we see a lot of things that they sound simple. So you just go like, okay, draw the legs, draw everything. It's simple, like drawing a horse, but then you just add these tiny steps. And yeah, I'm trying to be fun. So that is the goals for this talk. So that was the first part, the why I'm here. I want to talk with you a lot about measuring using the platform we have, about optimizing using the platform. Then I'm gonna reflect about why we are all here, and then some closing thoughts. So the first part is over. Kudos. So for the next part, I would like to start with a bit of a reflection. So if I said this web app is fast, what does it mean to be fast? And I'd like to propose an exercise. So if you guys had to summarize web performance or being fast in one metric, what would be your pick? For example, like load time, responsiveness, what else? I really want to hear from you. So if you could, I'll leave that for 45 seconds. And I want to collect the opinions of you about that. Yeah, it's crazy because 45 seconds sound like a lot of time, but when you have the silence, it's like a weird silence. But yeah, I want to hear so much from you that I'm gonna be giving out stickers, or if you're the first one to answer, I got discount codes, or I can pay a pint. But yeah, another 10 seconds and we're good to go. Or maybe we could be good to go now. I think most of people can. So for this, for the next step, I have this one demo. Basically, what's happening here is I have this input field, and I'm typing things. And you can see that as I'm typing on the right, it takes a lot of time for the numbers to show up on the left. And there's a point that I got to stop typing, so otherwise my Chrome is going to crash. And then I have to wait for a given delay, and then I'm going to see the numbers. And then I have to wait again to see more numbers, and that's like really poor experience. And you could think, okay, this is like a virtual example. You are kind of on purpose blocking the main thread. But examples of that happen a lot out there. And that's why we have behaviors that are, for example, this one that is called rage clicking. So it's when we as users, we want to get so much one thing, and it's like taking some time, so we start clicking more and more. And it happens so much that we even have metrics to properly address that. So we have, for example, first input delay, or time to interactive, and others. And that's the thing. A lot of loading metrics, they don't capture the real user experience. We talk a lot about loading, but that's only one part of the thing. And we need to think in terms of which metrics actually get what matters. So yeah, we hear a lot of people bragging on Twitter, on conferences, and etc. Like, okay, my app is loading in this amount of time. And yeah, this is a fine slide. But the thing is, load metrics are not a single number. And back to the question, I really hope this is going to work. Yeah, live stuff is always. So yeah, those were your answers. So we have a lot of load time response. Yeah, the ones I mentioned. We also have interactive, load. Yeah, we have load a lot of things. If I were to list some metrics that we should measure, I would start first with perceived load speed, for example. That is how quickly the app can load and render all of the content. Oops, misclick. There's another thing that also has to do with load, that is load responsiveness. So okay, everything loaded, but how much it is necessary for the JavaScript on that page to run and the page can become interactive. We have then runtime responsiveness. That was, for example, the issue in the first example. So everything was loaded, but still there was some complex operation happening in there. And we also have smoothness. So it's like about the animations and the transitions in the app. Are they flowing as they should? And actually, we even have more metrics. We can, for example, measure how much of unexpected layout shifts are happening on the page in a way that the user's like, oh, I didn't expect that to happen. That's not good. And we have a lot of tools in the lab that we can use to measure that kind of thing. Lighthouse is one of them, but we have like a huge suite of options these days. But the thing is, the only way to truly know how our app or site or whatever is performing for the users is to measure that as they are using that. And I have one example from history. Has anyone ever heard about this guy? Great. Yeah. Otherwise, it wouldn't work. So basically, this guy ran the first experiment with real users that I know in history back in a couple centuries ago. And basically, he gathered 200 monks all together, ironed then, and he ran a current, like an electric shot through them. And basically, with that, he was measuring the latency of the electricity. And he happened to discover osmosis back then, measuring latency like that. And nowadays, browsers, they do give us like a lot of APIs native in the platform that we can use to measure and to make our stuff faster. So we can go from this to stuff I didn't know, because I cannot say what you know or not, so that's the whole point of the talk, stuff I didn't know. And measuring with, let's start with measuring with the platform. To make it easier, I gathered 4 different groups for that. So we have the group that is general stuff, and those are going to be like APIs that are the basis for the other APIs we'll see. Then we have timing APIs. There's basically about figuring out how much something is taken. And then we have profiling and sensors. So starting with general stuff, we have done high-res API. That's basically the metrics for, not the metrics, basically the basis for everything we're going to see. And the performance observer, layout and stability, and page visibility. Page visibility, let's start with that because that's one of the most simple ones. So basically, this is the full code to use this API. We can either access the current state of a browser tab, or we can register an event listener. And that's really handy because there are a lot of scenarios where you can use that. We can cancel network requests, for example, if the browser tab goes idle. We can suspend like not only sockets, but any kind of communication going on. And we can pause interactive stuff like videos or carousels or any kind of heavy animation we might be doing. And there's even more stuff we can do. So we can start fetching, for example, things in the background. Let's say we did code splitting, and we have like parts of the bundle that are not necessary at this moment. We can start fetching them when the browser tab is idle, and then once the user's back, they're gonna have the full thing. We can use that to monitor, for example, if they're scrolling or navigating from one specific part of the app, and okay, apparently users are leaving when they get to this, so it's another kind of metric. And you can throttle things like set timeout or any other things that you have scheduled over time. The other one is performance observer, and this we're gonna see it a lot throughout the whole session. So it's basically a way that you can subscribe to almost any kind of performance-related event, and basically you register callbacks that are gonna be fired when the browser is idle. So that's good because it doesn't prevent it from doing any kind of work. The API is gonna be almost the same. So you instantiate this performance observer object, and you have this type. So basically, we'll have different types of entries that we can start listening to. And before we see a lot of things, let's just talk about layout and stability. That is one of the uses we have. So many websites, I don't know if that happened to you, but it has happened a lot to me. So in our websites, we have elements shifting because something loaded. So we have parts of the app. We start loading something, maybe a request or something that is async, and then once it's done, then pooh, something shifts in the user. And that's not good from the UX perspective. So we can use the performance observer to spot these events. So we listen for layout shift events, and it's gonna give us something like this. That is basically a lot of metadata about that one event, including, for example, if it was triggered by some input field. And the thing is, we can use that with some tools like this. This is the film strip view. And we can use that one API with that, and we can spot layout instability. So this one example is in my personal webpage when I was fetching my avatar from somewhere else. So I had this blank space with nothing, and then the text, and then after a couple of seconds, you would see this avatar in the blank space. So that's considered bad, for example. And once we spot that kind of thing, we can do something to address it. Like, for example, add some skeleton library, like React Content Loader. So we are probably very familiarized with these from maybe Facebook, Instagram, or actually this kind of resource is common like everywhere these days. So yeah, that was the first part. The timing APIs, I split them in two parts. So yeah, to make it easier and not to bore you out. So the first part is these three: user timing, element timing, and event timing. So user timing is the most generic one. Basically, we create marks first and before and after making some operation, and then we do this measure thing that is basically calculating deltas on top of our records, and then we observe for measure. And the first thing is that this plays really well with the developer tools we got in the browser. So for example, you can see the highlighted the two events that we marked using this API. And we can use that with a lot of custom metrics that we can create. Like for example, to check whether the styles or the scripts on that page finished blocking, or whether the fonts were loaded. And of course, we have libraries for doing that nowadays, but under the hood, libraries are probably doing that. And to check whether some element like a hero image or some important part of the experience was displayed. And this plays really well with other tools. So for example, this is a speed curve that is an observability tool for front end. So you can register user timing entries, and you can, for example, watch how they evolve over time, like for the good or for the bad. The other thing is element timing. So as the name suggests, it's about measuring render time of stuff. And the good thing is that this one is the basis for largest contentful paint. That is one metric that we hear a lot in Lighthouse, for example. And the API is quite simple, actually. It's just this HTML attribute that you can add in some of the elements. Unfortunately, you cannot add it in all the elements. It works with images, text blocks, and like a small subset of HTML stuff. And this is the kind of response you get from the API. So again, you have a lot of metadata about how rendering for that one element happened. And again, this plays really well with other measuring tools like speed curve. That is, you can track it over time and track the key parts of the app, for example, how they are evolving over time. And not only speed curve, you can use like other tools and you get like similar results. And last but not least, we have event timing. So event timing, I love the names. So it's about the time for processing something. And it's the basis for first input delay. So it is the basis for the issue that we had in that one first example. And again, we use that with the performance observer, and we listen for first input. And here we can, for example, calculate the first input delay using some values that the API gives us. And we can use that to measure the latency of different kinds of things. For example, we can measure the latency from the moment we click on something until, for example, let's say we have a table and we have some huge operation going on when we want to reorder, maybe we want to filter. So we want to measure how this is how long it's taking. So that's one example. Or if we have a slider that is basically a way to filter data on a huge dashboard. So these are scenarios that we can use to measure that. This is my favorite part, profiling. For profiling, we have long tasks, which happens probably to be the most popular one. And we have user agent specific memory and JS self-profiling APIs. The long tasks one, as the name suggests, it is for spotting things that are taking too long, like our input in that one example. And it has this hard value of 50 milliseconds, and it's not like a magic number like the ones we use in CSS. It's more like, because it's based on this user-centric model called Rail. And it's also useful to detect when the main thread is blocked, because that means you don't have your UI is not responsive. And it's so important that it's the basis for both time to interactive and total blocking time. And by the way, these are the long tasks. We can spot them in DevTools as well. So the same things we spot in DevTools, with this API, we can spot them when they're running in our user's machine. And this is what it looks like, for example, when the main thread is blocked. So not only the input fields, but also any kind of input, or any links, anything we have, once we block the main thread with the long task, it all becomes unresponsive. To use that API, again, the observer, and then you watch for this one specific event, and then as a result, it's gonna give you like metadata about the event. For example, not only the duration, but also what triggered that one long task. Following that, we have the self-profiling API. So basically, you instantiate a new profiler. So this one is not using Performance Observer. And then you start doing like whatever that you think is heavy stuff. And then you can, for example, track in a service or somewhere else the stack trace you'll get for that. And it's really handy for profiling operations that you know they're gonna be like heavy stuff on the main thread. Or it's also handy, for example, when you include some third-party script and you think it might be causing some performance issue, and these things are more common than we think, you can also use that, for example, debug that. And you can combine that with other metrics that we saw or that we're gonna see. Last but not least, we have the user agent specific memory. So it's a long name, and in the past, we had a similar API that was the JavaScript heap API that basically we would check the memory heap in the browser. But this one is an improved version. It's more, they're not doing the same thing, but it's the best way to measure memory right now. And it works based on waiting for garbage collection to happen. And if it doesn't happen, it's gonna force after 20 seconds. And that's really helpful because memory leaks, they are really, really easy to happen in the browser, even though we don't think. So, for example, when we forget to unregister some event listener, or when we don't close a worker, or when we have like sparse arrays, or when we accumulate a lot of objects in arrays. And there's this session by Google Chrome. It's really interesting. It's only about spotting garbage collection problems. But if I were to mention one example, would be this. So can you see where's the issue here? Or even better, is B gonna be garbage collected? Yeah, no, yeah, because that's the thing. In browser, garbage collection happens not because of use, but whether it's accessible or not. And B is accessible if we do, for example, object.b. So because of that, we have this memory leak. So sometimes memory leaks are tricky in the browser, and with this API, we can measure like that. And it's especially helpful, again, just like the profiling one, when you have apps that handle a lot of data in the browser. So from my experience, I can remember 2 scenarios. One of them was, for example, when we had a map that would plot 100,000 data points in this one box map. So this was perfect for spotting issues. And that's also helpful when you're introducing new feature, or you want to A/B test something to figure out whether you are introducing or not technical debt when it comes to memory. And when we see all of these free APIs together, like the kind of results that they gave us, we can kind of see the potential we have for better understanding what's happening in our app. The second part of timing. So now that we took a break from timing, we can talk about it again. So on the second half of timing, we have resource, navigation, and server timing. For resource timing, as the name suggests, it's better. This is the full resource cycle in the browser. And the resource timing APIs allows us to visualize that. For example, checking whether something was fulfilled via cache or not. So if we have some part of the app that we expect it to be cached in the browser so that it doesn't have to be fetched again, we can use this API to monitor whether this is happening or not. And the amount of information we can get from this API is really huge. I don't expect you to read all that. I just wanted to show that it's really a lot of information. And with navigation timing, we can also, for example, inspect the time to first byte. That again is probably some metric we've heard from Lighthouse or some other laboratory tool like that. And we can do a lot of combinations possible. Like we can check whether our service workers are working as we want them to, whether they're properly caching, or we can check some parts of the response time from our stuff. And the last one is server timing, and as the name suggests, this one is meant mostly to be used in the server. So it's based on HTTP headers that you send in this format. So you have one metric, you add the duration for this one metric and one description for that. And it's really handy to measure anything that's happening on the server in a way that can be seen on the browser. I'm going to add a screenshot in a minute. So let's say anything that might be taking some time in the server, like authenticating some requests, or running things from a template engine, or calling other services like an email service or something like that. So let's say, for example, we want to tell the browser how much it's taking for the database and the templating processing. So we would send these headers, and in the browser, once the front-ender opens developer tools, they would see this. Like, I know it's kind of short, but it shows in developer tools how much the exact values we sent. So I like to see this metric as one way that you can use to that backenders can help front-enders help them, because when you're inspecting something on the front end, you can, okay, this is the issue, and you can directly approach the backend. Okay, what's taking too long is this part of the thing in the backend, so they can straightly address that. And you have a lot of tools out there to make it smoother to adopt these APIs. So most of them comes as middlewares. So we have middlewares for Node.js servers like Express, but we have also middlewares for Java servers or PHP servers, etc. Last one, session sensors. These are probably one of the most popular ones, and it's really short. We have battery and network information. So battery status, again, really simple API, promise-based. We can check information about the current status of the battery, but also how long it's gonna take for it to, for example, to run out of battery, or you can check whether it's charging or not, or discharging. And you can register event listeners, and this way you can adapt the experience when the user has got not a lot of battery, for example. Then you cannot run something that's going to take a lot of CPU on a low-end device. On a similar way, we have network information. So again, we can check the current status, and we can register an event listener. And this is the kind of information we have. So it's going to tell first whether it's like 2, 3, or 4G connection, or even if it's a slow 2G connection. It also has this round trip time that it's really helpful. An estimation of how long it's taking for downloads, and last but not least, whether on a mobile phone, for example, the save data mode is activated. So that's really helpful, because if you're on an iPhone and you activate data saver and you have a web app, you can, from the web app, identify that and, for example, not download things. And we have tons of possible use cases for that. So you can switch. One of my favorite one is switching between high and low definition for content you're serving. So for example, if the user is on 4G, you can show a video, but if it's 2G or 3G, you can show only the thumbnail, and then if they click, you play the video. And it's also helpful when you want to decide whether to preload some resources or not. So if you want to download a bundle that the user might need in the future, that might be a good thing. But if they don't have a lot of data, that might be a bad thing. So using this API, it kind of helps you making that one decision. And a lot of other decisions, you can defer things based on that. And you can even adapt to situations when they are offline. And you can even force offline mode. So for example, I've seen in video call apps when the network is so bad that they won't allow you to call at all, because they cannot kind of assume that it's gonna be like poor experience. And again, you can warn users. That's another really common thing. So if they're gonna download something, it's like, oh, you're doing that over your data. You're sure you want to proceed, and that kind of thing. And last but not least, metrics. So you can, for example, gather data about the network of your users. This is one example with React. So we're basically, based on the connection type, we are checking whether we want to render a video or a high-end, like a high-resolution image or a low-resolution image. And this concept isn't new. We have posts from back 2018 about the idea of connection-aware components. And we even have libraries, for example, this one, that they give us a lot of hooks using network information and battery status to allow us to do things in React. And this is one example, like Twitter does that. So if the user has enabled the data saver mode, they're gonna render only this low resolution preview, and then if the user clicks the image, then they're gonna see the full image, and then you're gonna download that. Woo. Yeah. Now we can talk about improving with the platform. Halfway, guys. So the first thing we have are resource hints. So basically, resource hints are work on the assumption that if we can predict some kind of behavior or some action from the user, then we can optimize based on that. And they are really simple. We're gonna see that most of them are just HTML attributes that we use, but they are effective if done the right way and based on metrics. So they look like this. Hopefully you can read. So you have like pre-connect, preload, DNS prefetch, and pre-render. And you use these attributes in links, or sometimes with script tags, or sometimes with images. And the first one in this list is pre-connect. So this one is really, I would say it's probably the least popular of these ones, but it does help a lot. So basically, it tells the browser to start setting up connections with the server. So this includes, for example, TLS negotiations and handshakes in TCP. And depending on your context, this helps you reduce a lot of round-trip latency. So it looks like this. If we trace this timeline, where we have first our HTML loading and then our CSS loading. Let's say we use custom fonts. Let's say we have 2 different fonts in our web app. So after that, we can start loading the font, the first font, and then the second font. And only after that, we're gonna see them rendered on the browser. If we pre-connect, we can move this bar to the very beginning, because we can kind of tell, okay, go ahead and start connecting to Google Fonts or whatever it is where we have our fonts. The second thing is DNS prefetch. So as the name suggests, it's about domains. So it kind of warns the browser about what domains it needs to look up for. And again, it reduces the overall load time. And this one is really handy when you have resources outside of your domain. So on a CDN or on something like Google Fonts, as I mentioned, or some other domain. Prefetching is about doing stuff in the browser idle time, so it starts fetching what you need for a page in the background, but it doesn't get to render. But the thing is, it's tricky because it's about working with predictions. So we got to be really sure that we are fetching stuff for a route of our app that the users are actually going to visit, because otherwise we're just spending their connections. And pre-render is just the same, but one step further. So we not only prefetch stuff, but we even render in the background. So you can be providing a really smooth experience where the person goes to a route of your app and everything is already prepared, but at the same time you have like an even higher gamble, because you're not only spending network, but you're spending their processor. The other thing are priority hints. So basically, they allow you to either increase or lower the priority for some scenario. It can be, for example, the largest. If you have something that is supposed to be your largest contentful paint, maybe an image, a hero, some key section of the app, you can increase priority for that. And you can, for example, use that to decrease priority for things that are not visible to the user in the first moment, or as we call, above the fold. And we can use that, for example, to reprioritize the scripts as well. So this is how we use priority hints as an HTML attribute. So we have fetch priority, and this can be either high or low. And again, with images, or so in this one example, we are setting a high priority for the header, or it could be for the logo, anything that's key to your experience. And in the Caruso example, we are setting a lower priority for things that are only the next images, so we don't need them right now. And we can also use that with scripts. So whether we have some library being added, we can play with the priorities, and we can also do that with the fetch API. So this is like an extra configuration we can pass. So basically, we set priority either low or high. So that's really helpful for example, scheduling things. And by the way, we'll speak about scheduling in a minute. We also have responsive images. So basically, this is from Google, this data. Yeah, images in the desktop and the tablet, they can be like 2 to 4 times larger than the mobile ones. So if we only have this one set of images, what's going to happen is either the person on the desktop, they're going to have like not so good resolution, or the person on the tablet or any other mobile phone or any other mobile device, they're going to be downloading extra stuff that probably don't need. So with this one extra HTML attribute that's called source set, we can avoid that. So it basically looks like this, and it doesn't replace the source attribute as an extra thing. And basically, you can set, for example, different versions of the same image based on some ratio or some width ratio or some device pixel ratio. That was this. The next two things are native stuff that we are used to have our own solutions. The first one is native lazy loading. So we have plenty of libraries out there for doing lazy loading. But now we have this in the browser as well. So it looks like this. Again, an attribute that you can say loading equals to lazy. And for now, you can use that with images and iframes. And basically, it works like this. So if you have something that is off the screen, if you don't use that, you would be probably downloading that. If you use that, then you will see that these contents, for example, images, are only going to be downloaded in the network tab as you scroll and as they become available in the viewport. And there are even some studies, as always by Google, on the results of that in some different companies. And they figured out that lazy loading iframes had really, really good results. So it helped reducing the first contentful paint, and it also helped reducing the first input delay. And I had some good results as well in my previous company where we started lazy loading iframes where this API was available. And the last but not least in this section, and I know I said this before, but this one is really my favorite one, is the native scheduler. So if we think about scheduling in the browser right now, we have some primitives. So we have set timeout, we have set interval, we have both request animation frame and request idle callback. And if we have workers, we also have post message, which acts as a scheduling mechanism. But the thing is, scheduling in the browser is tricky because we have to use the same scheduler. So React has a scheduler. Some apps might have a scheduler. For example, Google Maps, they have their own scheduler. And having more than one scheduler probably leads to resource fighting amongst these different schedulers. And this happens because we don't have proper scheduling primitives. And last but not least, we still have to think about the browser work. We still have to think about rendering, garbage collection, etc. So this is kind of realization in the front-end world these days that we need better scheduling primitives. And people are aware of that. That's why we have this API that's on the way. And basically, this native scheduler is supposed to be a more robust solution that is directly integrated into the event loop. And most of the things are promise-based, and it allows you to control and schedule things in a more flexible, but at the same time united way, so that you don't have each framework or each app sometimes implementing their own scheduling solutions around the very few primitives we get. And the good thing is also really, really well aligned with the work that the React core team has been doing. They are even part of the discussions. And not only React, but Polymer teams, some teams at Google and Chrome, and the whole web standards community, they're all working together on that. There's a really good talk, by the way, about this whole topic and doing both on and off main thread loading. This one APIs, this new API is kind of an umbrella of APIs. So my favorite ones are these four: post task, uid, wait, and is input pending. Let's explore some of them. So post task, as the name suggests, it allows you to schedule something to be executed, and it's promise based, but it's really configurable. So you can, for example, define different priorities. It can be user blocking, or it can be something that doesn't have like really good, not high priority. We can also define delays for some tasks we post. And it gets really, really nice when we start, for example, working with task controllers, because then we have signals and we can check the status of signals, and we can also use them to change the priority of something from background tasks to blocking or vice versa, and we can even abort some signal. So that's really great scheduling that nowadays we would only get if we use the library or something like the React scheduler. And Airbnb, for example, they are already using some parts of the APIs, the ones that are usable, for improving their experience. The second one is input pending. So it's part of the navigator, that's scheduling, and you can basically use that to stop doing something if you have to handle input. So it would be like a fit for the problem we had in the beginning. And the nice thing is that you can even filter what kind of inputs we wanna listen to. So we can, for example, just say, okay, I'm interested in mouse or in key down advance. And this one is a work mostly of Facebook. And again, they're using, and this is like another signal that it's really, really aligned with the React team. And the last one for this API is the uid one, and most of this API is probably the most abstract at this point out of this umbrella, and most of the examples are just like it's a promise-based thing that basically allows you to uid execution back to the browser, and we can combine that, of course, with is input pending, for example, to resume doing something if there's no input pending. But I think that this library is called main thread scheduling. It's not a polyfill, but it's basically heavily inspired by the spec. And if we check this library documentation, we have like better examples. For example, this one, where we are going through a lot of files and all the lines in this lots of files to perform some search operation. And if we get the uiding thing in our mind, we can go back to the example we had before of the input problem and etc. And we can think, how could we improve that? So this is the source code for that one problem. And this resourceful operation, I'm kind of mimicking something that's really heavy. It could be, for example, some data filtering or something like that. We could turn that code a bit and, for example, promote it to a generator. And inside this generator, we uid execution back to the browser. So if we see that, these are going to be the results. So as you can see, this API is compatible with suspense, if you're familiar with React suspense. And you can see that at no moment I cannot input. Like, it's really smooth. And of course, I'm going to see sometimes that it's performing some CPU-bound operation, but the UI is smooth all the time. And this is the full code for that one. I don't expect you to read it. I just wanted more to show that it fits in 40 lines. So that's the key thing of uiding back to the browser. And I was like this when I figured out about these things. But there's much more. So there are things we can do, like with CSS, for example, we have font display swap to avoid fonts having to wait until they're rendered. We have wheel change to optimize animations and transitions. we can import something once it's visible, like a component, using intersection observer. We have also send beacon for which is another scheduling primitives. We can combine canvas and workers with using off-screen canvas. So that's a really good way of offloading canvas stuff outside of the main thread. And there are things on the server as well. So we have this thing called HSTS, and basically it allows you to skip the round trip latency that you would have from going to HTTP to HTTPS every time. You know, every time the user types HTTP and you want to send them to the HTTPS thing. So there's one example. And you can avoid even more extra round trips with the quick protocol part of the HTTP free umbrella. But even though a lot of these things are interesting and etc., I love this session by Kites that's called You're Not Facebook. So most of us are not building schedulers or performance monitoring tools on a daily basis. So yeah, you can use observability services like Calibre or SpeedCurve or others. We have libraries like Core Web Vitals by Google that, for example, it comes out of the box in Create React App and some other applications. And even some platforms like Versal, they have their own analytics solutions. So yes, I would say that most of the times observability services that have SDKs built on top of the APIs we saw, they're gonna serve our purposes. But we can enhance them with libraries like Web Vitals, or we can create our own abstractions on top of these and framework-specific abstraction like custom React hooks. And this is kind of related to the next part, that is move fast and break nothing. So yeah, you got the reference. So for example, some of these APIs, we're gonna see that they're available in only a subset of browsers. So they're not available in Firefox and Safari, for example. Some of them are available everywhere. And you might be wondering, okay, how can I use them if I have users from different browsers? I don't think it's a yes or no question, but one solution I came up with when I needed to was this library. It's like alpha, so don't use it, but just get the abstraction. And it's basically a library for doing pattern matching in React. And basically, let's say we have this app. It's supposed to render videos from previous NDC Oslo editions. And this is the full code for the app. We have suspense wrapping that. And you will see that I'm using this with components and the match components. This is the key part. And why suspense? Because I'm lazing loading these components. So I'm lazing loading video and the preview components. I'm using the library from Google I showed, like that is use network status. And then I have these three components, with, switch, and otherwise. And I'm pattern matching on top of the network info. So the other important part is the suspense part, because this is the key for having the conditional imports. And then I use with against the different possible cases. So it can be 2G, it can be not supported, the API might be not supported in the browser, like Safari, or it can be 3G, 4G, etc. So for example, Safari users where this API is not available, they would see that. So they would see that the API is not available, and because it's not available, I'm not taking the risk, I'm rendering the video. But if you are in Chrome, and this is the example, yes. If you are in Chrome and you have like a good network in the API, you're gonna see this. So it's a 4G connection, I could detect it, and I'm rendering the video. But if you are in Chrome, and here I'm gonna simulate like low-end mobile with like bad internet connection, what you're gonna see is just a preview of the video. And the other interesting thing is, in these scenarios where I have, you will see that in each scenario, I'm downloading only the bundle. So here, I'm downloading only the preview, and here, I'm downloading only the video. So no extra chunk of code is downloaded. That's not necessary. So going back to why we're here, basically, we build all these tools to run in browsers. And it's quite common that we not usually care a lot about which browsers are visiting our app. I myself sometimes forget to do this exercise. but whenever I do, it's always interesting. So for example, this is some monitoring data from the last 3 months about which apps, which browsers we're using. So of course, we're gonna see Chrome, we're gonna see Safari, Edge, and all of these mainstream browsers. There's gonna be Explorer in there as well. But the cool thing is when you start exploring more, especially if you have like a lot of visitors. So you get to see things like this. And the more you scroll, the darker it gets. So you're gonna see, for example, Blackberries, you're gonna see Nokia, and you're gonna see even PlayStations accessing the app. So yeah, we have a lot of browsers out there, and you know what else? What are browsers? These. So in-app browsers like LinkedIn, Instagram, Facebook, they are all browsers, and not only they are browsers, but sometimes they have like huge shares depending on the market you're targeting. And these browsers, they run on different devices and different connections. And for me, that was one kind of reality check when I saw that research that basically is, the first input delay was 7 times worse for mobile users. So it's easy to visualize when you see a chart. So check out how much more yellow and red zones we have for mobile users. And not only that, but it's usually easy that we forget about bandwidth of our users. So we still have some parts of the globe that are where the vast majority are either 2 or 3G connections. And we can see that reflected, for example, across the kinds of connections accessing Twitter and the kinds of connection accessing Jumia. This is like one of the big e-commerce in Nigeria. And not only that, but the global 4G picture is like that. So having 4G doesn't mean a constant connection speed. So this is how much it can vary from a country to another, all LTE. And these connections, devices, and browsers, they are used by people. And research shows that basically how long it takes to load the app or performance in general for people is the top 1 priority, even more than, for example, whether it's easy to use or if they could perform the activity they meant to. And I love like some researches in this area because they're really funny. So the first one is from back in 2009, when they figured out that 40% of people in the UK, they become physically violent towards their computers. Years later, they did a similar thing in the US, and it was again 33% of Americans, they had either yelled or screamed or even physically assaulted the computers. And then in the same year, there's another really interesting research that is basically showing how this impacted the conversion rate or the engagement in the app just because of frustration. And fast forward time, I love this one because it's basically how much the delay in a web page. So they basically mimicked a delay. They virtually delayed the thing. And they had ECG devices attached to the people. And basically, this is the effect of that in their heart rates. And then people from like doctors, they figure out that this is kind of like watching a horror movie alone. And of course, this reflects in the behavior in the browser. So yeah, more than half of the people are going to abandon your app or your site if it takes more than 3 seconds to load. And it's crazy to think that even it changes from one part of the globe to another. So people from different parts of the world, they're going to have like a different threshold or a different limit of frustration. And there are studies around that show, for example, that being mad with an app in the US is different than in Germany, that is different in Australia and Canada. So this is how important it is to actually think about how our users are feeling, because this directly impacts business. And it's crazy to think that, like we know that long tasks, they do affect the time to interactive, for example, but it's crazy to see how much this changes your conversion rate. And it's crazy to see how much it's also worse in the mobile. So in mobile, they take up to 12 times longer, like long tasks 12 times longer. And actually, half of the load time could be spent just running long tasks. And it sounds terrible when you say like that, but when you visualize the conversion rate on a chart decreasing because of that, then it's even worse. So back to why we're here. Basically, people use way more different browsers than we tend to think, of course, depending on your audience. And 5G and 4G is not the same across the globe, and sometimes it's really limiting. And yeah, having 4G and or 5G and how fast it is changes from one part to another of the globe. And yeah, anything that slows down or prevents the users from accomplishing, yeah, this is an obvious one, prevents them from accomplishing this goal is going to cause frustration. And people are going to quit apps or sites because of frustration. So, some closing notes. Oof. On top of that, the first one is always try to associate like business metrics and performance metrics, because we see more and more, especially on social networks or some solutions or some libraries, they gaming metrics just for the sake of that showing they're fast. But if you do correlate business metrics, there's no way to game these metrics, because that's actual behavior from the users. That's like your conversion rate. That's the actual impact. And it's usually a bad idea to assume that people are going to have like not only fast connections, but also fast devices. It's crazy to see the amount of low-end devices people have. And that's why it's important to test on real networks and on real phones, real devices, and to collect field metrics. I know a lot of these APIs are exciting, and we could start using them like tomorrow, but it's also important to avoid the observer effect. So it's like when you're, for example, watching some really beautiful animal and you scare it because you're watching it. So try some of these APIs, they might be heavy or they might impact the performance of your app. So it's important that you don't change the performance of your app because you're trying to track the performance of your app. It's also important that you get rid of the noise in the metrics. Mostly in huge scale apps, we're gonna have like bots, and we're gonna have like lots of things that are generating numbers, and that might be confusing to our reports and to understand the full picture of our app. There's no silver bullet. None of the solutions I presented, for example, are gonna work in 100% of scenarios, and none of the metrics I presented are gonna be relevant in 100% of the scenarios. So it's important that you identify the core metrics for your business, for your app. And I know it's a cliche, but yeah. One of the things I like is this quote by Edward Deming. So in God we trust, others must bring data. So yeah, just trust data. Don't trust me. 8 years ago, I was saying that Angular would be the future, for example. And nowadays, I talk about React. It's not a direct conclusion, but it's a closing thought, though. We're hiring in Medallia in a lot of parts of the globe. So if you want to do interesting stuff, if you want to work in performance squads, reach out. The slides for this one session are going to be available in my speaker deck profile. So yeah, you can scan it. All the links are going to be there. If you like that kind of topic as well, I have other sessions about performance and about internals of web APIs and internals of React mostly. If you want more information about Medallia, or if you want to see other sessions, this one sessions, everything, this is the go-to link. As I announced, I do have stickers. So if you're that kind of person like me, you can just reach out. Let's have a chat about performance or whatever, and then get some stickers. And that's all I had. I don't think we have time for questions. If we do, you can have questions. If we don't, I'm going to be around. Let's chat. Thank you.
Okay, are you all ready for the last talk of the day? I know it sounds like, oh my God, I don't want to be here anymore, but it's just like, yes, it's been a full-on day and we're all ready for some beer, right? Yeah. Okay, so we're all here to basically learn about playwrights. I'm going to ask you a few questions in a minute, but let's just first of all, I'll just do some introductions first. My name is Debbie O'Brien. I'm a senior program manager at Microsoft, and I basically I'm advocating for playwrights. So my job is to make sure the community of playwright grows, that we have content, videos, everything that you need in order to learn playwright and be successful in testing. So that's my job. Easy job, right? Yes. I'm an international speaker. I've spoken in many places, including Antarctica, which is my claim to fame. That was an amazing conference on a cruise ship in Antarctica. I'm a teacher, open source contributor. Playwright is open source, so you can all contribute to that as well. And you'll normally see me, if you follow me on Twitter at Debs_O'Brien, you'll see me like literally running, cycling, and doing sport all over the place. This is me running in Oslo the other day. It was a beautiful day. And yeah, I try to do about 3 hours of sport a day, which is something, I know I can see you looking at me go, what? When I was locked up from COVID and we weren't allowed to even leave the apartment for 7 weeks, that was like hell. And then when we first got out to be able to do sport, we could do 2 hours of sport a day. And it made me realize that like the only person that's stopping me from doing what I want to do is me. The government stopped me in those times, but then it's me that's stopping me. And I was constantly saying, I want to do more sport, I want to do more sport, but why wasn't I not doing it? So now I kind of say, right, I get up in the morning, I do my 3 hours of sport, and then I go to work in the afternoon. And because I work on America time, it suits perfect. I'm saying that because, you know, I've won a lot of awards, as you can see, but I do not spend 12 hours a day in front of the computer. I enjoy my life. I love my job, but I also love my personal life as well and doing things for myself. So make sure you're also taking time out of your life. Do sport. If you don't like sport, you know, walk the dog, water the plants, do whatever it is you like doing, but do not sit in front of the computer for 12 hours a day. It's really terrible for you. Okay, enough about me. We're here to talk about testing. Simple question, are you writing tests? That is not bad. That is good. I know some of you are like, yeah, I know I should be doing more. Okay, hands up. Who is not writing tests at all? One person, 2 people, 3 people, 4. Okay, you're very honest. That's great. So those of you who are writing tests, what are you using? Are you using Selenium? Anyone, you can talk. It's like, it's fine. Are you using Selenium? No. Okay. Are you using Cypress? Yes. Ah, interesting. Okay, good. Any other testing frameworks? Yes. Okay, good. Okay, excellent. So there's a few of them. Okay, brilliant. So let me just ask a few more questions. I want to get to know my audience. JavaScript developers? Lovely. .NET developers? Okay, we are half and half. That's good. So I've made this talk to be 50-50, right? Java developers? Good, I haven't covered you. That's oh, there's one, sorry. You can take a seat, though. Okay, and Python developers? Okay, lovely. I'm not covering you either, but you can still watch this talk and go home and do everything. PHP developers? Good. I think they're all dead. That's good. Okay, so let's continue. Testing. So what is the problem with testing, or what I think the problem is with testing, and you can agree or disagree. When we start a test, kind of like testing is hard, right? It's really hard to get junior developers on board to get them testing. Any other problem getting junior developers on board to testing? Or is it easy, all junior developers are testing? No? What else? What makes testing difficult to get started? Anyone? It's boring. I love that. I'm going to change your life. It takes time to learn, right? And people don't have time. I'm running for 3 hours a day. Well, I don't run. I cycle for 3 hours a day. I'll run for an hour and a half. But yeah, we don't have time because we have, you know, more important things to be doing. It takes time to build. Right? When we're running our tests on CI, it's like, oh my gosh, you know. So that's another pain. Time is money. The product manager is coming along and saying, I need it shipped now. Just delete the test. Don't even bother writing tests. Just, we want this out in production. It'll work. It'll be fine. Your code is always great. Lovely. And we don't have a very good testing culture, right? We're literally not used to testing. We put testing as an afterthought, something we do after we've finished everything. If I have time, now I'll test, right? What if we had testing as the start of something, as like part of the normal day-to-day? Let me give you the example of Twitter, right? Twitter are doing alt tags on the images. If you're sending a tweet now, you can click that little button and add an alt tag. Who of you are actually putting alt tags on your images? Okay, that's terrible. We need more of you doing that, right? This is really important because it includes other people. Now, I started to do this, and it's like, oh my God, it's taking me now 4 minutes to send a tweet instead of like a couple of seconds. But I'm making my tweets more accessible. Now that I'm in the habit of doing it, I just always add an alt tag to all my images on my tweets, all right? And you can go and check my Twitter feed. Sometimes maybe I might slip, you know, we're not perfect. But getting into the habit of doing something means that then it just becomes normal, right? Like brushing your teeth in the morning. You don't even think about it, it just happens. Testing, we need to fix that culture so that testing just happens and it's not an afterthought. So how do we do that? How do we get more developers to write tests? Do you have the answer? Anyone? Make it fun. I love that. Anyone else? Make it easy. Excellent. Anything else? Make us save time. Yeah, so we can all go running. Excellent. So that's what we're here to do, right? And I'm going to show you Playwright because that's what I believe Playwright does. It makes it easy, it makes it fun, and it makes you save time. So let's have a look. So Playwright testing. First of all, who has heard of Playwright? Not bad. That's about 40%. Excellent. Who is using Playwright in production? 5 people. Don't worry, I'm working on you. I'm working on you. Okay, so Playwright is reliable end-to-end testing for modern web applications. It works in any browser, so you can test on Safari, which always has problems, and any browser, any platform. You can also test iPhone. You can emulate, test iPhones and Pixel, etc. One API. Full isolation, which means when you write your test, that test, everything is like isolated. So the next test does not need or can't get anything from the other one. It creates a whole new browser context every time you're writing a test. So network caching, all that kind of stuff, everything is cleared. Cookies, state, nothing gets carried forward, okay? So that makes your tests less flaky because that test, if it breaks, it has nothing to do with any other test in your whole application. It's just that one test, whatever went wrong in that test. Very fast execution. All tests run in parallel, and they run for free in parallel. We don't have to do anything to make that happen. It's just out of the box. And then powerful tooling, which I'm going to talk about today, and it's multi-language, which is very important, especially if you're working in a company that has a lot of teams, back-end developers, front-end developers, who are using different languages. And then they just have to learn one framework, and then they can still use that language of their choice to write their tests. And everyone's just learning one thing, but writing in the language of their choice. So we support Java, JavaScript, TypeScript, Python, and C#. So you can write your tests in any of those languages. So you're all here today for that. So the Java and Python people, I will not show you any Java and Python code, but everything that I show you, you can do in Java and Python as well. And I will show you JavaScript, TypeScript, and C# today. So I'm going to show you a little bit on the VS Code. Anyone using VS Code? Excellent, beautiful. So this is my favorite way to get started. If you're not using VS Code, that's totally fine. You can still start. It's not too late. But no, you can use the terminal for everything as well. I just like showing in my talk VS Code extension because it's very visual. It's also a very easy way to get started or to show someone very quickly and get them introduced into testing. So with the VS Code extension, you literally search for it. Make sure you find the one that says Microsoft with the blue tick, because there's a couple of other ones, and this is the verified one that we basically keep control of. So once we've installed the extension, then we literally type install Playwright and up in the command panel. And what this does is then say, okay, which browsers do you want to install? Do you want to install Chromium, Firefox, and WebKit, all of them? Or maybe you just want one for whatever reason, that's your choice. And also it asks you, do you want a GitHub Actions workflow? And this is like really cool, right? Because, you know, then obviously I want a GitHub Actions workflow, because once I select that, it's going to create that for me. I'm just going to push my code to the repo, and every time I basically create a pull request or push, it's going to just run my tests. I don't have to do any work. I was creating the documentation for this. I was like saying to the team, but what do they need to do to get it work? And they're like, nothing. I'm like, no, I need to document this. What are the steps? And they're like, it just works. So I'm like, how can it be it just works? It just works. So literally that's the documentation. Literally you just upload it into the repo and your tests will run on each push or pull request. So that's great. If you're using GitHub, it's amazing. So if you're getting started with C#, then you have to do this create project, .NET new console, cd into that folder, and then add the Microsoft Playwright package, a .NET build, and then you'll do that install to install required browsers. Once you've installed, you'll get something like this when you're installing with JavaScript. You'll get the GitHub folder there that I just showed you. You'll get an example test that we created just so you can get tests running very quickly. There's also a test example, which is a to-do demo app, and you can go into that in your own time and play around with that and see all those tests. And then you get the Playwright config, which you very rarely have to touch because everything just works. But if you do need to configure anything, or maybe you want to add mobile testing, for example, then that's where you configure that. If you're in C#, then basically after your install, you'll install NUnit and Microsoft Playwright NUnit. Then you create a test file and basically run the test. So pretty easy. Running tests, you can run all tests, a set of tests, a single test, and tests, as I said, run in parallel. So they just, whatever test is ready. So it's not like in, one test number and then number 2 and number 3. They all run in parallel. And it's super fast. So I'm going to show you running the example test that comes when you install using the VS Code extension. And you can see I just pressed that little green button of play. And bang, up comes the browser window, right? You missed it. I know. Sorry. I'll do it again. OK, so here we go. We're playing. And it was just a very simple test. So it's there's not a lot to see. And that's the basically example test. So if you want to just install and show someone, this is what you're going to get. And this is how you're able to demo that to someone and say, this is the test running. If you want to run the test in headed mode in C#, then you'll just have to add this code, which is basically putting headless equals false, and then the slow-mo equals 100. And then you'll be able to run that in headless mode with .NET Test. So live debugging, I love this feature in VS Code where you can actually live debug. So, I mean, we never have bugs, right? But the one time that you might have a bug, you're able to fix very easily in VS Code. So again, this is just the example test that I have, and I'm just going to walk through it. So the text equals get started. I'm just going to change to star. And I'll run that test, and it's going to break, right? And it says to me, error, there's a strict mode violation. And basically, Playwright found 3 possibilities of the word star and didn't know which one to click. So it's like, I don't know which one you wanted. So I can create a breakpoint right here in the code, and then I can run in debug mode. Once I do that, in the browser window, it's going to select what Playwright was telling me. These are the 3 things that have star. Star appears in all of these words. Star appears in getting started. It appears in get started, and it appears in the word star. So then I can play around with this, and I can literally say, all right, instead of star, let's put started. And it's going to say, oh, there's 2 started. There's get started, and there's getting started in the footer. So this is not going to work either. And I can play around with this. Look, I write the word Playwright, and there's like 12 of these, right? So this is showing me how many possibilities there are of these selectors. So get started will fix that test. But as you can see, I can play around and see it, run that test, step through it, and now the test will pass because I have the right selector. To run tests in C# in debug mode, you'll use the pw debug equals 1.net run. And this is one I actually did in .NET, where what it opens up is a little bit different, right? So this is going to open up the inspector, so it's a little bit different to what I showed you in VS Code. Also, if you're using the terminal, this is what you'll get. You'll get this inspector window, and you're able to run through the tests like this. And you can see as we go through each one. So this test broke on the listen together on the listen together text. So as I stepped through one by one, I didn't create a breakpoint in this. I was just stepping through and seeing it happen. And you'll see down at the bottom that's the log that's happening, and you can see the explore there with the text equals listen together. So as I was debugging this, I'm like, okay, this listen together is not here. What's going on? And you can play around and say, right, okay, text equals room code. I can see that one shows up. I can see that in my window. But listen together, it's kind of like coming up in the corner, but it's not on the page. There is one down at the bottom, but it's together. It's not listen together. So you can kind of see what selectors are available to as you're clicking along here. And then I can see down here the error it's giving me. It's waiting for the selector text equals listen together. The selector resolves to hidden h1 tab index equals -1. Attempting to click the action, it's waiting for the element to be visible, enabled and stable, but the element is not visible, so it's waiting. And then Playwright said, I don't know where this is because it's just not there. So this is a way of kind of like figuring out, where is that selector? I can't see it on the page. So if I can't see it on the page, Playwright can't see it on the page, and then Playwright can't click it. So that's a way of kind of testing that your selectors are there and debugging using the terminal or using C# as well. So locators, what are locators? You've just seen a couple of locators there in the code. Locators are a way to find elements on the page at any moment with built-in auto-waiting and retryability. That means Playwright will wait for that to be ready. It's not just going to click it. It's going to wait until it's ready on the page to be clicked. And then if it's not working, whatever, it'll retry automatically, and it will try again after a certain time. So you don't need to set timeouts unless your code is really bad and your JavaScript takes so long to load, it's going to take 10 seconds, and then you need to do that. And they're nodding because they're like, I've written that code, right? Yeah, so write better code. So because Playwright is fast, I think it's 3 seconds is the default, but you can change the default in the config if you wanted to. But yeah, basically write better code because Playwright will wait for it to be ready unless it's like way too long and it's like, this app is terrible, right? Locators are written like this. So you could say const get started equals page.locator, text equals get started. So the locator, and then you've got the selector. I'm using a text selector here. You could use a CSS selector. You could use a role selector. You could use XPath stuff if you really want to. So there's a lot of options there. You can put IDs, test IDs in there. So you can choose which one you want. And basically choose the best selectors, right? The text, that text shouldn't change, and that's what the user will see, right? If you're using CSS classes, maybe it makes sense to use them. Sometimes it does, sometimes it doesn't. If you're using Tailwind, for example, then you're going to have a real hard time putting all those classes in. So maybe that's a good idea then to create a test ID and use the test ID instead. So the same with in .NET, you'll have say this is a page locator with a header, and inside the header there's a navigation, and I'm expecting it to have this array of featured podcasts available on powered.net. So it requeries those given selectors, and it waits until it has all 4 elements with the given text. Web first assertions, there are a lot of assertions, so you can go through to be checked, to be disabled, to be editable, to be empty, enabled, focused, to have class, to have count, to have ID, to have JS property, to have screenshot, etc., etc. Very similar, as you can see, if you're working in C#, pretty much the same, just sometimes it's capitalized, and then you just have async in the end. So to be checked async, to be disabled async, to be enabled async, to have value async, etc., etc. So make sure you're using assertions, really, really important, because this is what is going to create that await for you and do everything as it should do. Okay, now I'm going to introduce you to my best friend. Are you ready? Meet CodeGen. CodeGen will generate your tests by recording your actions, right? You said you want tests to be fun and you want tests to be easy and you want to save time. This is CodeGen. Now, did you go to the GitHub Copilot talk earlier? Anyone? Yeah, so this is kind of similar-ish. GitHub Copilot is amazing. I think it's great. CodeGen is great. Obviously, it's AI, and we need to make it better. Well, it's kind of AI, but it's we need to make it better. We will make it better, but I like it for getting started. I think it's really easy. So let me show you how it works. So again, this is using the VS Code extension, and I'm literally going to click that button there that says Record New. This is in the testing sidebar. So when you first install Playwright, you have the little kind of sidebar testing icon. It probably is hard to figure that that's a testing icon, but it is. And when you click there, you'll get this testing sidebar. And then you'll have that Show Browser, which we see in open the browser. We got Pick Selector to pick a selector. And then we've got Record New. So we're going to click the Record New. So once I click Record New, I get a browser window. But also in VS Code, I get a test-1 spec file already created for me. So now this is created in my project. So I'll go to a website. I'm going to go to the NDC website. And you'll see that code was just written. Await page, go to NDC Oslo. So let's, accept those cookies. All good. We love cookies. So that's accepted, and it's written that page. Text, all good equals click. I'm going to click on the heading here. Now, the user wouldn't normally click on the header, but I just want to record that because I'm going to change it later. And I'll go down and have a look. What's going on this page? What do I want to test? I mean, join the NDC party. Yes, I want to go here. So I'm going to learn more. This is the only thing I'm interested in this conference. So I'll click on the Tuesday event. Let's see. I might sign up for that one. That looks good. And this will open up another browser window. And I can test across multi-domains because this, as you can see, is a different domain. I can see that community Tuesday. And I have no idea what that button says, but I'm sure it says sign up. So I clicked it. And then I'm like, the Fjord. Who's going on this cruise, on the Fjord cruise? Yes, I'm going on this. Excellent. So I'm going to see you there. I signed up for this as well. So again, I can check that that button works and brings me to the page. So I went to another page. And the NDC party, there's no sign up for that 'cause it's free, but the PubConf, right? So I'll sign up for that. And then I've gone to another page, the PubConf page, and I'll click on that, just on that text to make sure it's there. I could buy the tickets and continue that testing. And then I can go back to the first one and I'll say, right, I'm going to open this chat here and I'm going to say to the conference organizers that I basically really want to come to the party. So I'm going to type this in here. I would love to come to the party. And I'm going to send this. This is an iframe here as a chat. I'm going to send this. Oh, and they're like, yay, you can come. And they're like, no, you have to fill out your name. Oh, God. Here I go. So I'll fill out the name. And then I kind of went, oh, no, you're not getting my email. So, and there's my test done. So literally, just by clicking around, as a user would normally do, I have now got all this code generated for me, right? That's just super cool. This is the test, literally as it is, right? And you can see all those, everything that I have clicked through. You can see page one was, so page is actually the first page and page one is actually the second page, if you think of it that way. So every domain there is a different page, and you can like go back between those pages and you can test across those multiple domains. So if you had those payment procedure stuff on different domains, then you can test your application throughout those without any extra work. You can test iframes without any extra work. It just works as you just seen there. So it just uses the frame locator, iframe, and it will check everything. So that's my test with very little work, and that's how I get to do 3 hours sport a day. See? Easy. And I can run that, and you can see it's running, and it's going to go to those domains. It's going to check it. It's super fast, but it checked everything, and happy days, right? It's cool, right? Yeah, are you convinced now? Yeah, kind of. All right, so this is, yeah, let me show you this, because when I actually ran this, it didn't really work. The test broke, because sometimes, you know, it's just clicking around, and sometimes it will work, and then you go, oh, but sometimes it doesn't work fully, and sometimes you got to like adapt your code a little bit and improve your code, right? Because yes, we didn't do any work, let's make it better. So what happened here was, it kind of like looked for that iframe, and the locator was text area, and it was clicking on it, and it was like, no, this is not working. This is wrong. So I'm like, okay, what did I do? What went wrong? So we can have a look in here. So we know it's the iframe. The iframe is the that chat thing, and we can go along and we can check on the first page what we need to select. So what is actually what we need to do? So we can pick the selector, and we can say, right, the selector, as I'm clicking along here, the SVG, no, we don't want that. And we can say, oh, look, there's a div there with an ID. So that's kind of the one I really want. That's a better select. And I can click on that. Once I click on that, it's going to save it in this pick selector box. And then I can just press enter, and I now have it. And I can paste it in here. And now I have a better selector for my chat. And this is now going to work. So as I went through, I'll run this and you'll see that it works. So sometimes, as I said, sometimes you might have to go over your code and just check a couple of things. Now if I go back, the test works, right? It's all green, so that's great. Did it actually work? Do I really know? Well, let's go to the first page. You can see my name, Debbie's, on that page, right? So that did work. So I fixed my little selector problem. And now there's a couple of things I can do to improve this, right? Because the CodeGen does not do assertions for me. It's just doing clicks. And you saw I clicked on the heading, and a user would not click on that heading. But I did that because I'm just lazy and I wanted to save time. Because now I can transfer that from a click to a assertion. And actually this one is a click, so that should stay. The text is all good, so that should stay. But this one has text, okay, NDC Oslo, that's the H1. And that one is an assertion. We wouldn't be clicking that. So we want to say expect that locator to, and you can see everything that we can have to be checked, to be close to be defined, to be disabled, to be empty, to be enabled, etc., etc. And we go down until we find the one that we want. And I just want it to be basically visible on the page. So I can select that. I want the H1 to always be visible. And then I can go along and say, okay, what else? So learn more, we clicked on that, that's good. We expect the page to have URL, that's good. The next page, we want it to have that event to pop up onto the next domain. And sign up, yeah, we want to do that. But the same H1, right? The H1 has the text of Community Tuesday. That's an assertion. Let's change that from a click to be an assertion. So we want that to be visible on the page every time we go there. And then we can go along to the next one. And the next one is that start. I cannot say this. Pamelitigan. So yeah, we want to make sure that's clicked. That's cool. Again, another H1. That shouldn't be a click event. That should be an assertion. So let's go and expect that one. And we can go and add more on this, right? I'm just doing a basic example here, but you might want to also check that the image is there. The image has the alt tag on the page, that the button has an area label. You can do all that testing as well, right? But this is just a simple way of taking your code generated and literally going through it step by step and just improving it and adding those assertions in. So here we've got an image with the alt equals pubconf because that was actually an image. It wasn't a text, but it has an alt tag, so that's perfect. So we just want it to be visible. It's already testing. It has the alt tags. That's great. And then we have our iframe that we fixed, and we put the right locator in there, so that's going to work. And we're also checking that we typed in, we put caps log, and you can see what I filled in. I used the fill, and I would love to come to the party, so that's good. And then we clicked on the button. It only found one button in that frame, so that was in that iframe, so that works perfect. And then we've got a locator of placeholder equals name, and we want to fill it with Debbie. And there's my test, right? Again, we could continue on and then press that and see what happens. And I don't know if they email me back, we could test that. But that's our test done, and we can rerun that test as we've finished changing it to assertions and visually see, does that test still run? And I can go back to that first one, and my name Debbie's is in there, so that test works. I can go home happy, and everyone is going to get paid and yeah, have more free time on a Friday. So if you want to use CodeGen in C#, then you'll basically use this code here to run it, or if you're using the terminal as well. And it's a little bit different then in VS Code and using the terminal or using C#, but the same. Two windows will pop up instead, right? Instead of having VS Code, you'll have two windows, the browser window and this inspector window. And from here, you can just go to the website. I'm going to test a different website this time. I'll test the .NET Podcasts website. So I put that in, and you can see my C# code there. It's a waiting page, go to async. Await the page locator has text. So again, it's doing the same thing, just in C# instead of in JavaScript. And as I click around this site, it's going to basically start recording all the actions I do. So let's take let's open this one here, this podcast. We'll click on this one, for example. We can see, like, as I was testing this, some of the images were broken. So I was like, oh, look, I found this problem. Like, I don't know if they fixed it, but you can check. But yeah, as I was actually just writing this test for this talk, I was like, wow, look, there's an issue here. There's a problem here I've come across without even writing the test. It'll test the image alt is there. So that's good. It has an alt tag. So as you can see, as I'm running through this, for the first time, I'm actually kind of seeing if there's any kind of issues, and then I'm creating that test, and I'm able to then like go along here, inspect it, find out what went wrong in this. This was a case where they had the image alt tag was coming from the back end, was the same as the image name, and then if you had like, you know, a little gap in between it or something, then it didn't work. So simple things to fix. So that's the tests running in CodeGen. Do you like my friend CodeGen? Yeah, it's kind of cool, isn't it? Yeah, we give CodeGen a clap. I love it. I think it's great. We're going to try and put web first assertions into CodeGen. It's in the works, so it's not going to be there yet, but look forward to that, because I want to be able to, like, you know, click on that header and it knows that, you know, actually you're not going to ever click there. That's not a click event. Let's make that an assertion and expect it to be visible. That's my hope. It's going to happen. Just takes time, but for now it's a pretty good start to get things going. So let me show you some reports, right? This does only work for JavaScript, TypeScript. So this is the show reports. It's a HTML reporter. We don't have it for C# yet, but a lot of people have asked for it, so we may have it. So just watch that space. NPX Playwright show report. This is something you cannot do in VS Code extension. You need to use the terminal. So we've got all the way up to here without ever even opening a terminal, which is pretty cool. But now, if you want to report, you need to do this. So when I do this, I'll get basically a report. And let me show you basically, as I write the command, the difference now is that it's actually going to run all the tests on all browsers. So VS Code normally just runs it on one because it makes it quicker when you're basically just writing your tests. But once you run it with the terminal, it's going to run on all three browsers. And it's running the two tests I have, that example test and the test I created. And that's why you're seeing 6 passed, right? So it's really fast to run two tests on 3 different browsers. So 6 passed very quickly. And then I'll just show the report. So the report opens up here on a 127.0.01, and I can just like click it, or I copy it over into my browser window, and here is my report. So the report will tell me everything that happened in my test, and you can see it goes through step by step. So I could click on each one, I can see which tests I've passed, how many flaky tests, how many failed tests, on which browser it was run on, how long it took, and basically like, you know, see at all times what's going on. Now the trace files, we can do with npx playwright test -- trace on. This is if you want to run it just locally because you just want to see the trace files. I'm going to show you what the trace files are, so bear with me if you have no idea what I'm talking about. But the trace files normally would be run on CI/CD, and it would normally run on the first retry. So if on continuous integration your test fails, it'll go, oh, something happened there, let me run that again, and then it will record that trace, and then it will run it again, and then you'll have that trace on that retry, and you'll be able to go through it, debug it, and see what happens. If you're using C#, then you'll just have to add this code in here to basically get it to run. So you'll say screenshots true, snapshots true, sources true, and have the path trace.zip. Set that up, and then basically you can drag and drop it onto the trace website, and then you'll be able to see the playwright trace. It's like a PWA, so it's local. It's not like nobody can see it unless you host it yourself, but it's basically a local PWA, but you can send that zip file to anyone and they can basically open it and see it. I'm going to show you back to the JavaScript version because this is what you get when you do it locally with npx, and you'll get, I don't know if you can see it there, but there's a little kind of like icon with 2 bars, and it's like, it's a terrible icon because it doesn't like tell me that that's a trace, but that's the icon for the trace, and if you click on that, will open the trace. So let me show you. So this little icon here, I can click on, or I can actually just go into the actual test itself, and I'll see a nicer image that's easier to click. So I'm going to go to the test that we created with CodeGen because I want to see this one because it's more fun than the example. So this is the trace viewer. And what I can see here is I can go along a timeline, and I can see absolutely everything that happened in my test at every single point in time. For every event, that locator text equals all good, that the click one, the H1 there, this is my click event. You can see the different colors change depending on if it's a click or if it navigated. And I can see the whole screen, the website of what's happening there. And I can basically just hover over here. This is waiting for an event. Then it has text equals Community Tuesday. As I go along here, it's what was the next one? It was the frame was received on the new page. And you can see now I have a new page underneath, right? So I can basically just scroll down in the timeline, and I can see that other page. I can go back to the first page. I can go back and select the next event. We went down to the Fjord cruise. I can go down to that page, see what was happening at that time. And then we have the pubconf one. I can go down to that page and see what happened there. And basically see at all time over those multi-domains, I can see a whole thing of what happened throughout the tests in my own time, scrolling along as slow and as fast as I want to go. But I can also go along here and click on every single action. So I can stop and say, right, what happened here? I can see what's happening on the page. I can see everything's loaded. So here the text equals all good. You can see that red dot where it was clicked. That's the action. What happened before that and what happened after? So the cookie box went away when I clicked on it. So I can actually see that that's exactly what should have happened. This is great. And again, I can click through every single action, and you can see that it's moving, right? It's scrolling there, right? So it's not an image, okay? This is not an image that you're seeing. This is an actual DOM snapshot you're seeing. So something to take into account. You can see like the animations happening there, right? It's a full-on DOM snapshot. And yeah, I can click through all this action, before, after, what happened. This is great for debugging, so if you have any errors, you can go through this and you can really understand everything that happened in that test and why it wasn't working. So again, going through here, you can see the call on the other side, the locator.press, the locator.fill, the locator.click. You can see the time. You can see this is like, here's my pop-up box came up, and you can go over here. There's the value Debbie that was added in, so it gives me all this detail. The selector was the iframe, and before and after what happened. So you can see my name came up there and after, but before my name wasn't there. And I can actually type in it, right? Because it's a DOM snapshot. So it's actually editable, so I can literally type in here, right? Which is kind of cool. I just think that's cool. Yeah, so it's fun. And then you got the console. So if I had any console errors, I could see them all in here. Here's there's an error here, so I can see, right? There was something went wrong, so they should fix that. Then there's a network request. So I can see the network requests that are happened. There's like 2 aborted images or something going on there. So again, I could report that to them. And I can see the source code of the test. So even though I don't or didn't write that test, I can see the actual source code and actually then send it to the developer and say, hey, look, you missed this. I see the error. And you can see it was running Chromium and is mobile false. This looks a bit bad because I just zoomed in so much for the talk, but normally it looks much better, but you can see exactly how that's run. So that's the trace viewer. It's really, really amazing for debugging and really, really helps. Now, if you want to configure a test for mobile Safari, which is basically really easy, this is, did I do the right one? I'm recording the video here. And no, this looks like the wrong video, damn. So yeah, if you're going to configure them for mobile, basically what you do is you go into the config. Oh, I recorded a new test, that's it, because the test on mobile just passed, and I want to show you something different. So I'm going to record a new test that just clicks the menu, right? So this is a new test. It's just going to basically test the menu. I play that, I run it, and this works. It's perfect. Okay, very simple test, just testing functionality. Now if I want to test this on mobile, right? I want to make sure, because, you know, menu navigations on mobile, just always a disaster. So I can go into the Playwright config file. So here you can see it down here. And it's already like there. So I can just literally scroll down and you can see it's commented out by default. So I've got the mobile Safari and I'm just going to test on mobile Safari. And I could also test on mobile Chrome, on Edge, on devices Pixel 5, on everything, right? But let's just do mobile Safari. And now when I run this test, because I'm using the VS Code extension, it's going to take this one, it's going to run that one. I could configure it to basically only run to run all of them if I go in and configure that, but I just want to run this one. When I'm in terminal and you run test, it's going to run every single test. So just keep that in mind. If you're using the extension, it's going to run just that last one you did, and use the terminal if you want to see every single test and get that report. So I want to see the report, and you can see there that test has failed. Right, so I've got a problem with my tests. Actually, 2 of them have failed. So the first one failed and the second one failed. So let's go and inspect why that failed and see how we can improve that. So it said like strict mode violation on the iframe. That was the first one we looked at earlier. So I could go and debug that, or I can go in here and see this one failed, which is has text tickets cannot be found. Right, so this failed on mobile, and we'll have a look. And you will see like there's like, once it fails, it stops the trace, right? I couldn't go any further. So it recorded up to the point that said like, I have no idea, I can't continue, I'm broken, you need to fix me. And it's like on this text here, right? Has text tickets is not there. The selector resolved to hidden. It's attempting to click the action. And I can inspect this, right? Because this is a DOM snapshot. So it gives me all the access to Chrome developer tools, just like any website. So now I can go along here and I can start understanding what's going on in my website, and I can kind of see, right, well, I get this, right, because has tickets is not there, because my mobile menu is obviously different to my, you know, other menu, so it's not there, it's hidden behind this hamburger menu, okay? And I didn't tell Playwright to click that hamburger menu, so it's basically not going to find it. And I can, you know, search through and kind of understand the code, because maybe I didn't write that code. As I'm writing that test, I'm kind of saying, yeah, okay, so that tickets are there, it's just, it's stuck under a nav menu, right? So I can now go along and fix that test, write a better test that includes that. Any idea how you would fix this test, how you would actually make the test work for the mobile menu? Anyone? No ideas? Check for what kind of menu you have. I like that, it's good. Anyone else? No? Very easy, we can use isMobile. So you can basically pass in the isMobile fixture and say, you know, if it's a mobile, I want you to await the page locator navigation menu, because you need to click that menu, and then you can go and do the has text workshops or has text agenda or whatever. But you need to click that menu each time. So when I'm writing this test now, I need to basically go back, and every time I need to put if is mobile, you need to click on the hamburger menu, because that's how the mobile functionality works. The menu never stays open like on the desktop. So I've got to like tell Playwright, if you're on a mobile, click the hamburger menu, then go and click that. If you're on a mobile, click this. If you're on a mobile, click this. Or we can say if you're not a mobile, do etc. Right? So you can use whatever. And then when I run that test, you can see it clicked it and it opened up and it clicked it and opened up, clicked it, opened up, and my test works. Right? So that's an easy way of making sure things work and testing across mobile and across desktop. Very quickly, I'll show you another simple example there in C# when I was running the .NET podcast one, and we found an error with the, you saw it earlier in the video, with the listen together text, right? And as I was searching along here, and I'm like, I did not understand what was going on, and I started using the developer tools to kind of figure out what was happening in this scenario. So this is, like I said, it's a really great way of debugging, but also understanding the code. And in this one, it's like, okay, listen together, the text is not there. I went through everything. I was like, why are you not there? Like, what is going on? And I can see it's actually here, right? The text is in the H1 class is there. So I've got a H1. The test is broken because looking for the H1 and the H1's not there. On mobile, it is not there. On desktop, it is. I can see it in DevTools, and I found a display none. Damn it. What developer decided to, on mobile, put a display none on the H1 heading? So I tried to understand, what did this developer do? Why would they do that? And how can I fix this? So yeah, I went to the actual desktop version, and I could see that listen together text, that H1 is there. And I'm like, okay, so it's there, and then you've got like that other thing underneath it. But if you look at the, when I put display none on, that text is there, but a H1 is at the bottom of the page, right, in the middle of the page. That's not the right order. So this developer basically decided, okay, flex is too difficult, and this is putting it down the bottom of the page. Doesn't look good, so let's just remove it from the page. Yay, solve the problem, I go home. And then Playwright went, this is not good. Okay, so it's a great way of finding your problems that your developers have, put into production and gotten away with. So keep that in mind. So you can run your tests on CI with GitHub Actions. We talked about that earlier. This is basically the actions that it creates. So this is done for you. You don't need to do anything with this unless you're doing component testing. If you're doing component testing, there's another run that you'll put in there with the component testing, and you'll add that to it. It will run your end-to-end tests and then your component tests. And then you get something like this on CI in your actions, and you'll have your failed ones, your passed ones, and you'll be able to go in those and check your workflows and go down, and you'll see there on that failed test, I've got that Playwright report. I can then click into that report, and I've got that trace file. I can download that trace file. I can use I need to use the Playwright server to actually serve it up, so just keep that in mind. And then I'll run that and figure out what went wrong, or send it to the developer and say, fix this, this broke. So yeah, component testing. Anyone writing components in Vue? Yeah, a couple of you, not too many. React? Oh, lovely. Svelte? Nobody? Angular? Yeah, a few years. Okay, sorry, we don't have Angular support. So yeah, component testing. Maybe we will do one day, but component testing is run using Vite. So this is why we don't have Angular, because Vite is not supported by Angular yet. So if you were doing component testing, you need to install this npm init playwright at latest --ct for component testing, and this will basically allow you to write components and test components. Now, very simply, you can basically just create your components and run them. I'm going to test just the message prop there. I'll run that, and you can see that this kind of comes up in the browser, so I can visually see my components rendering on the page. I can remove that prop, and then I can run that test, and I can also visually see that that prop removed. There's nothing there. The test broke. It tried. It was like, where is this prop? And it kind of said, hey, I expected Vite and Playwright, and I got nothing. So, what do you want me to do here? So I can add that back in. That test will work. And I can go through each component one by one, and basically just press the play button, open the code. This is testing a slot, for example, in Vue. Test that the count is included in the vslot count. And this will come up, and there it's beautiful. It's included there. And then I can test that the count component actually counts. So this one should be clicked. Every time it clicks, it goes up 1. And bang, that count is 2. It's so fast that you missed it, I know. You can slow it down if you want to. But basically, this is a great way of creating components and then writing some simple tests alongside it. It doesn't take long to do that, so I suggest you do test your components. So then we've got the VS Code extension. So Playwright testing, right? You've got your VS Code extension, which I showed you. You've got CodeGen to auto-generate your tests, right? You've seen that. You can run in debug mode. You've got locators and frame locators, right? So you can test across iframes. You saw the show reports. You saw how to view trace files and debug your applications. Auto-wait is built in for all actions, right? So there's no need to set timeout calls. Tests run in parallel for free. It's super fast. Multiple browsers and multiple devices. We saw that. And it's also got intercepting requests, follows all redirects, bypasses cores, and manages cookies. So that's kind of cool. And basically, I just have really kind of one question for you. Are you ready to playwright? Have I convinced you? Yeah. Seriously, yeah, just tell me, yes, this is cool, or no. You can be honest. Are you ready to playwright? I love that. That's amazing. So my name is Debbie O'Brien, as I said. My email is debbieobrien@microsoft.com. I never really read emails, but if you want to send me an email, you can. The docs are playwright.dev. We've got a Twitter account, YouTube. We will have more video content coming. There is a community Slack channel, so if you do have any problems, just put them in the Slack channel. Playwright is open source. It's completely open source and free. It is by Microsoft, so we just have a lot of support and we can do a lot of stuff, but it's a community-driven project. So if you have a feature request, something you want, maybe you want Angular support, right? Then you create that feature request. If that gets upvoted, we do it. Everything runs through GitHub. Everything is in the open. You can visually see everything. And it's getting better and better each time. So I want something like the watch mode for components. So as you're building your test, it watches, and then we'll just kind of rebuild that instead of pressing play, because that extra second I just don't want to do, right? So that's kind of other stuff that we will work on. Component testing is experimental. So, play around with it and let us know your feedback. In general, I would love to hear your thoughts on Playwright. If you're using it in a company and have a lot of tests, we're building a case study page, so come and talk to me. I will be on that Fjord cruise because I booked my ticket. So I will be there tonight. If anyone wants to talk about Playwright on the cruise, please come up to me. I know it's the end of the day. You're welcome to stay back and ask questions. You're welcome to ask questions here. We've got a couple of minutes before we should finish. But I will also be here all day tomorrow. I'm not here Friday, but feel free to come and reach me, if not on Twitter, Debs_O'Brien. Thank you very much for your time. And if you have any questions, just put your hand up. Thank you. I know, everyone's like, beer, I just want beer. What time is beer, right? Any questions? Yes? How is the Shadow DOM support? Yes, there is Shadow DOM support. Both for components and for normal tests? Yes. Look in the selectors documentation, I think it's in, or selectors or location documentation, or just search Shadow DOM, but it's there, yes. Yes?
Does the mobile test have support for orientation?
Yeah, you can use the viewport size. So you can change the viewport. You can just use test use and then put in whatever viewport you want. Sorry? I think there is. I'm just showing more GitHub, but there's a lot of, we're implementing a lot of Azure stuff. But don't quote me on everything Azure because I don't do a lot of Azure work, but yes, there is support on Azure. And it's in the Azure Static Web Apps template by default now. Yes?
Intercept the WebSocket communication.
You want me to answer that right now?
In Playwright.
Slack channel.
Okay.
Yeah, no, check the documentation. There is some documentation on WebSockets. I haven't played around with that. If that documentation isn't good enough, chat to us on Slack, and we'll improve that or find out a way. But I haven't tested myself. But good question. Thanks. Anyone else? Yes, down here.
The application. So authentications. And
authentication. Yeah, so there's a great documentation on authentication that you can check out with some examples. Obviously, authentication is hard, right? Because it depends on what you're authenticating. If it's like, two-factor and needs a mobile phone to test that. So I don't have all the answers on authentication. But definitely reach out to us and tell us your use case and what you're trying to do, and we can try and point you in the right direction. Thanks. Anyone else? Going once. Oh, over here. I can't see. There's a big light. Oh, he's standing up. Sorry, yes. All the way over there.
So if you have lots of tests, and it's testing like end to end, and you change one thing, how much work is it to change all the tests?
What do you want to change? What are we talking about?
Okay, say you have a login that you're testing, and that's something you got to do in all of your tests because you got to be authorized.
Okay.
And you change something in the login things that breaks all your tests. What do you do?
So you shouldn't have any test that depends on another test, right? So all your tests should run independent. And if you have something like a login, you can use it before each hook. So before each is going to log in, so you could have all those tests on the one page. You don't have them on the one page. If you have them separate, you can use fixtures or page object model, and then you just have that one test that basically is doing that. So you're going to have to fix it only in one place. A good question. Anyone else? Yes? Not so much. I don't think we recommend it. As a .NET developer, I don't really can't go into whys on that. But but yeah, NUnit is the way forward. But maybe we might have in the future XUnit, but at the moment we don't have that support. Anyone else? Going once. Going twice. Yes, it is beer time. Thank you very much. I hope you enjoy the rest of the conference. I'm around all day tomorrow. Thank you for your time.